So good morning, everyone. It's good to see you again. And I guess so far we talked about databases, we talked about Java, we talked about web programming. Now it's time to go ahead, talk a little, regarding data structures, probably algorithms, and so on. And that is the reason we are here, right? So let's just get started with data structure, what data structure is, or before that, what all we need to know before we start with the data structure, what all we are going to see in a module, and then we will actually get started with the topic. So the very first thing, what is the prerequisite of the module? I guess I already typed it on your WhatsApp group. What is prerequisite of module is Java programming language. So I'm very sure you people had extensive work onto the Java, and you should be very comfortable. Probably this list I have already shared with you. Something that I said that you may not much need into the when it comes down to the data structure algorithm is like inheritance, polymorphism, or this kind of concept. So we need the fundamental of OOP concepts. We need the mainly language fundamental in the sense variables, if else, loops, switch cases, these kind of stuff we need it often apart from the other ones, right? So I'm very sure you must be knowing, as I said, that this particular module will be like more or less the practical oriented. It's like we'll be having more focus on actually doing the things than just knowing the concepts. And the language of doing, probably for your batch, is like Java programming language. So it doesn't make any difference, because when it comes down to the data structure, so it is language agnostic, we said. So whether you are done in C++, whether you are done in Java, whether you want to do it in like Python, whether you want to done like any other language, it is absolutely fine. The data structures always remain same. Yesterday someone asked me the question, and that is the reason I believe that I should also answer that, just for the better clarity of like everyone. There was a question that when we talk about Java, so Java has got something like a built-in collections. You go to the Python, or Python has got its own collections. You go to the C++, it has got like a STL. You go to the C sharp, it has also got its own data structures. So the question is, when the programming language already have kind of a linked list available, when the programming language already have got arrays available, a programming language already have got a library where the stacks and queues, everything is available, why we are learning it once again, or why data structure is kind of a separate module? If you ask me, there are like a couple of reasons. A reason number one is, the very first reason, I would say that the very first reason is like your thinking abilities. Your thinking abilities. The data structure module is one, probably where we consider few really small problems and few really big problems. A small problem could be like add a node into the linked list, or probably a kind of a big problem that find the what is the shortest path between 2 points in a city, something like that. So given a problem statement, how do you think upon it? So what are the major mechanisms, or what are the major thought processes behind giving any problem statement, like a thinking in the algorithmic way of thinking, like a first thing. The second good reason is that a lot of time people keep complaining that so we are not too good at coding. I always believe that data structure is like one of the module where you can be really good at coding, where you understand the algorithms. So you spend a little time in understanding algorithms. You spend a little time understanding algorithms, what algorithm is, how algorithm is, or like how it is going to solve. And then ideally, then you implement that algorithm into your own way, into your own way. So people who always consider that, sir, I'm a bit weak into the programming, this is always ideal. Like for example, you learn a selection sort. So you don't focus onto the code of a selection sort. You first focus onto the kind of a algorithm of a selection sort. You focus on algorithm of a selection sort. You understand its paperwork. You do the paperwork on your own. You make yourself more comfortable. And as you are comfortable on paper that I understood how algorithm is working, then you think of how do I convert it into a programming language. So programming language again, now programming language of your choice. So whichever language that you find it good, so you can, right? The third thing, fourth thing, probably why data structures are there into your syllabus. The one more reason, probably I would say that it is, wait for a minute. It is interviews, because it is very common that in an interview you have got like a questions on like linked list, questions on like a sorting, questions on a searching, and then again you have got question. So why these people are asking us? Are these people writing all the way, down the line, ये एक साल दो साल कंपनी में सिर्फ लिंक लिस्ट लिखाते हैं क्या? टू बी फ्रैंक, कंपनी में जाने के बाद में हम लोग कभी नहीं लिखते. सो कंपनी में जाने के बाद में what we actually take, what we actually use is probably the ready-made linked list. The ready-made linked list class is there in Java. A ready-made list class is there into the C sharp, into the C++. So things are ready-made available. But again, why in interviews we are mainly focusing onto the data structure? Reason is again same, that interviewer want to know that can you think logically? Can you think like whatever problem statement that you have got, are you able to convert it in an algorithm, in a flowchart? And then if you are able to convert an algorithm, are you capable of converting it further into the code? Is it possible for you? Now this is what again interviewer always ask you. So when it comes down to the interview, and probably interviewer is asking you, okay, go ahead, write a quick sort. If any person has written a quick sort directly in the sense without any kind of paperwork, the likely chances are that that person is out of interview. तो बोले sir, we are correct. Yes, you are correct, but the interviewer is not interested in knowing that okay whether you have mugged up quicksort or not. He is interested in what was your thought process behind that entire story. So how exactly you thought of, how exactly you are taken like a PO'd, then what kind of paperwork that you are done, what logic that you are put, and then are you able to convert that logic into a piece of code. So anyone who is saying that okay this is like algorithm, and this algorithm I have just by hearted and I have just written there are likely chances that in interviews you fail. So I'm saying that what we need to take care, what we need to focus on is obviously we need to understand given a problem. So first thing, we need to think. Second thing, we need to put it in like a algorithmic way, that how we can try to convert it into a computer algorithm, and then from the algorithm how we can convert into the code. So in my case, in my opinion, these all 3 points are important, and that is the reason we are learning data structures. So data structures we are writing is not for competing the Java framework. तो सर जावा का कलेक्शन फ्रेमवर्क है सर, मैं उनसे अच्छा कलेक्शन लिखता हूँ. नो, डोंट ट्राई टू डू लाइक दैट. सो हम लोग यहाँ पर उनके साथ कंपटीशन करने के लिए नहीं है. वी आर हेयर टू अंडरस्टैंड इट, right? And are we able to write it on our own? That is something we are looking for. I guess that gives you clarity why we are learning this Flow module, even though Java has got built-in collections or any other programming language has got built-in collections. Okay, what all we are planning to learn into this blog course is definitely we talk about some conceptual stuff like time and space complexity. Yes, definitely. We talk about linear search and binary search kind of mechanism. We talk about like recursion. We said recursion is something that you must be already knowing, but still, we will again go through the recursion. The reason is bit different, because this recursion understanding you also need it for one of some advanced stuff. So we will have a quick recap of what is recursion, and then how we can use recursion for solving certain kind of problems. Then we will talk about like basic sorting algorithm like selection sort, bubble sort, insertion sort or stuff. We will talk about the linked list. linked list concepts, linked list implementation. We will talk about the queues, we will talk about the stacks, and even the applications of queues and stacks. We will talk about. Then we need to talk about trees, that what basically the binary search tree is or how it can be implemented, and then more or less conceptual stuff. We need to also discuss what is heap or probably what is heap sort. But obviously, heap sort is kind of one of the advanced sorting algorithm. There are like other sorting, advanced sorting algorithms are also available, like you say quick sort or merge sort. Yes, we will talk about that. We also have got something called a hashing, hash table. I'm very sure in Java you already use hash map. But even though Java gives you built-in hash map, I want to learn, okay, how this hash map is like internally implemented. What is the technique behind it? What is the logic behind it? Can we write our own hash maps? Yes, that is what hashing or hash table concept. And finally, we will go onto something like graph theory, and not only graph theory, even graph implementation. Now you ask the question, how many days it needs? To be frank, I just recently we completed for the February batch. You might be knowing if your friends are there, and it took around 8 days to complete. Obviously, I cannot teach it at that short span, but then we will. My plan is that we will go for nearby 10 days, 10 working days, where we will talk about all these codes and algorithms. But then apart from that, something more, as I said, that it is about thinking abilities also. So there are two, three very common techniques of solving the problems. The problem solving techniques. What do you call it as a problem solving techniques? As I said that we will look more practically, but still you have to know what these techniques are. So there are two, three most popular techniques are there. The first technique, divide and conquer. I'm very sure you must have heard of this technique. And this technique, the divide and conquer technique, is something you call it as like a recursion. Yes, it goes around. The second technique I can talk about is probably greedy approach or greedy algorithms of solving the problem. And the third one is solved as a dynamic programming. And yes, we will be focusing onto all those as well. There are several, yes, brute force is there, or like many other are there. Uh, Something, the most popular, the most straightforward algorithms, most of the algorithms, they fall in this kind of category. So yes, apart from those, more of practical stuff, these are the conceptual ideas that we want to get. And obviously not only conceptual ideas, probably conceptual idea is like hardly for one slide, but after that we need to implement in a program, and then we need to visualize, oh, what exactly it means. Correct? So what I was saying is that so nearby 10 days it will take, where we can go through this flow module and we can try to learn all these concepts. As you must be knowing, and अभी तक आपको अंदाजा आ गया होगा. So as far as exams or like evaluations are concerned, I guess by this time you know the pattern. The very first thing is your theory exam, which is expected to conduct at the end of the course. What we usually call it as CDAC, course end exam, right? And you are expecting it somewhere into the March, right? The second one is your lab exam, again like a 40 marks, with a combination of like hacker earth or like some sort of problem, what is that, file upload kind of problems. But I believe that at this time there will be most of them, it will like a hacker earth based kind of questions. So 40 marks, and you can expect the exam to be on nearby 10th of January. You can mark a date. So like instead of like asking every day, sir wo exam kab hoga and when I should start preparing, so better you mark a date. I guess it is 10th of January, somewhere I guess it is Sunday nearby. So mostly it is planned like that. And a third one is probably obviously the internal exams. There will be some of the assignments check, as well as there will like a quizzes and etc etc. So this like again that will be like somewhere at the end of the module. You can expect it to be like 11th or 12th January nearby. So I told you that this will be something, our module plan. This will be kind of evaluation, what all we are supposed to learn. I guess it is enough of introduction, and we should really get started to understand what data structure is basically. Obviously, I have not written a very small concept that what is data structure, etc., etc. But yes, they will follow all the way, and we will begin right from a very fundamental question: what do you mean by data structure? Yeah, getting back. So, what is data structure? If you ask me in a very simple language, I would say that data structure is structure of data. What? Data structure is a structure of data. This is probably, kind of very much what I can say. This is kind of very much very diplomatic kind of definition where you simply say that data structure is a structure of data. But exactly what you want to talk about as a data structure? So basically, what I want to talk about data structure is that when I say structure of data, it mainly covers two things. The number one, how the data is organized in memory, how the data is organized in memory, how the data is arranged in memory. So like kind of contiguous memory hai, or kind of linked list kind of node, each node pointing to another node hai, or something different, something that it is organizing data in memory. And the secondly, I can say that processing the data. Secondly, like a processing the data, whatever data is available, you just do not want to see the data. You want to do certain operations on that particular data. So again, how the different operations to be performed onto that particular data. So usually when you say that I'm learning data structure and algorithm module, you are trying to focus on how a particular data can be arranged in memory, number one, and number two, how the execution can be done on it. Again, in both the lines, I should be using a word, something called as efficiently. So efficiently, I'm talking about efficient storage as well as efficient processing of the data. So, sir, what all different data structures that we have got, or different data structures that we have got? So we can start talking about. There are, again, this is not really the bookish one, but I would say that this is a rough division. You can say there are certain data structures which comes out to be like very normal, very common, and usually by default available in most of the programming languages. However, there are certain data structures which are, when I say advanced, they are quite application specific, and most of the time you need to build them by yourself. Getting back, so you talk about, we have got like an array. So you ask the question, so array is a data structure. So we have learned array in almost every language. Yes, you learn array in every language, but trust me, even array is a data structure where you say that the data is stored in a contiguous location. So array itself is a fundamental data structure, and you will not believe, probably it is one of the most commonly used data structure, which you have already used into almost every language that you have done. But you never know that, oh, it is a data structure, right? Going ahead, you talk about like a linked list, another very popular kind of data structure that we deal with. Then we talk about stack, we talk about queues. These are, we said that it is like a utility data structures. Utility data structure meaning by not for saving the data, but to process the data. So they are not for the storage, they are for the processing, and the intermediate data will be saved into that. So like a stacks and queues. You continue further. We have got like a trees bit, as I said, it comes down to the little advanced data structure. So we have got like a trees are for the optimized searching, that is like a main goal of a trees, but there are other advantages as well. Some more specialization, I can say that it is a heap. After you talk about tree, you have to talk about a heap, and then we can also go ahead and talk about a graph. Now these are the data structures which are not available into most of the programming languages. I do not say all of the programming languages, but I say that most of the programming languages, you may not see a ready-made tree is available, or ready-made graph is available. Yes, heap is available in at least few languages that I know, like Java, but I'm very sure you may not have worked on that. Like for example, Java has got a concept called a priority queue. The priority queue implementation of a queue that internally uses kind of a heap. So But that is the reason I just consider it as like advanced data structure. And this data structure usually you need to build it by yourself. So with this, but what basically the data structure is, what exactly we need to focus when we talk about data structure. So there is a word that always people use saying that data structure is ADT. What is ADT? ADT, is it advanced or something like that? No, no, not at all advanced. ADT stands for abstract data types. I'm very sure you come across the word abstraction during your OOP concepts. So abstraction, yes, abstract data type. What is abstract data type? Where in OOP there is like a foundation principle. You always say that what is there inside the object, what is there inside the object, what kind of data is inside the object, you do not bother. But what do you bother? You bother what all operations that you are providing. So you are not worried about what is hidden behind it. You are always worried about what interface is given. So when you talk about like a watch, you talk about a watch, you do not bother what kind of machine is used, what kind of chip is used internally or whatever. I said that it hardly matters. What I'm worrying a lot is how do I how do I use that watch? How do I see the time? How do I change the time? Now these are the kind of stuff that we are trying to focus on. Correct? So when it come down to the like external implementation, or when it come down to using data structures, we always say that it is abstract data type. And that is what you people have done in Java. So in Java, you always say that there is an array list. Now there is an array list, there is a linked list, there is a vector, and you found that almost all have got all kind of functionalities. They are giving you kind of similar kind of output. So you always say that key there are certain functions that I need to execute. So I need to add a data, or probably I need to remove a data, or I want to check whether the data is available, kind of contains method. And there is a method to search where is the index of method. So in Java collection, they have given you the built-in methods. So you do not bother about how it is created internally. Probably we never seen that whether they are using a kind of a node structure, whether they are using a kind of a array structure, whether they are using something different. Who cares? What is important? Important is that what add method does, what remove method does, what contains method does, what list iterator does, what index of does. So we should be knowing which all parameters to pass and what value, what results to collect. That's it. This is what all we look for. We never bother about how the implementation is done by the Java people. And this is something I'm saying is the abstract data type. So when it comes down to the data structure, you always say that it is abstract data structure. We are more concerned about the operations done on that than we are like concerned about how it is implemented behind the scene. तो वो एक आध एग्जाम्पल हो जाए. Yes, absolutely. Like for example, you talk about array as an abstract data structure. When I say array as abstract data structure, which all operation the array should have? Array के अंदर कौन कौन से operations होने चाहिए? I believe that array should have only two major operations. Only two major operations. One, I said that get element at a index. Get element at a index. And second thing is like a set element at a index. These are, I would say, kind of a primary operations that array data structure should provide. The basic minimal operations. Obviously, now using these operations on the top of it, there can be even advanced operations. The advanced operations like searching in an array, binary searching in an array, sorting of array. Correct? These are more or less kind of advanced operations on the top of array, but the very basic level operations are very simple: getting an element at a given index and setting an element at a given index. So you say that array is kind of abstract data structure which enables you for something called as a random access. Something called as a random access. So you want to access nth element directly, and that is what all you look for. Now you go ahead, you talk about another data structure. Let's say probably you must have heard of stack as an abstract data structure. Stack as an abstract data structure which all different operations are to be performed on a stack. I always give example. All operations that we need is that kind of a push element onto the stack. The second, we should be able to pop the element from the stack. Third, probably I can say we can pick which is the topmost element of that. And if you at all need the fourth one, I can say that is it empty? Is stack is empty or not empty? That's it. Now, what is again the primary behavior that you're looking for from a stack? The primary behavior that I'm looking for a stack is last in, first out. So I hardly bother whether the stack is internally implemented using array, whether the stack is internally implemented using linked list. Who cares? Or whether you are used tree or like graph, I don't bother. What all I bother is that the stack as an abstract data type we just talked about over here. So what functionality is being provided? What functionality is being provided? And on the parallel line, I'll take up one more example. Not all data structures that we will be discussing on a day one, but you go ahead. The another one, you can say that we can talk about a queue as an abstract data structure. Queue as an abstract data structure, you find that it comes with the same way. What is that? Push functionality, pop functionality, pick functionality, is empty functionality, obviously with the different intent. What is that? Here you look for first in, first out, isn't it? Yes, absolutely. So I'm saying that this is nothing but abstract data type. So while you implement, obviously you need to think of कि अगर मैं खुद का स्टैक का क्लास लिख रहा हूँ तो मुझको उसके अंदर कौन कौन से फंक्शनलिटीज देने हैं। अगर मैं खुद का क्यू का क्लास लिख रहा हूँ तो मुझको उसके अंदर कौन कौन से फंक्शनलिटीज देने हैं। डेफिनेटली आई नीड टू थिंक ऑन and definitely I need to implement it accordingly. But the minimal requirement, yes, we should be knowing in advance, and that is the reason we say that data structures are abstract data types. And that is the reason you will also find that the most common implementation, again I'm not saying that it cannot be done in other way around, but the most common implementation of all data structures are primarily done in an object oriented fashion. So you go to the C++, you go to the Java. So it is most common that people prefer making the data structure implementation in a OOP manner than in a procedure oriented manner. It's very common because the abstract data type, this concept closely resemble to the OOP paradigm, isn't it? So that was all about like a quick review, what data structures are, what are the like kind of rough classification, what do you mean by data structure as an abstract data type, as we will actually start working in the sense जब हम लोग let's say stack और queue पढ़ेंगे, we will talk about like what are the ADT operations, and then we will start implementing it. When we start discussing about linked list, we will again talk about the ADT operation, and then we will start discussing onto that. So every time you take up one and you start discussing it further. Now that is basically the idea. Then you continue further. Now we already seen what are different data structures. That is all right. But I told you that when I say that I want to organize the data into the memory, when I say that I want to process that particular data, and then I use a word saying that I'm looking for everything to be done efficiently. But the question is, what is definition of efficiently? What do you mean by efficiently? How do you say that whatever that you are doing is efficient? Because it is like a human nature that whenever you do something, you always believe that whatever you are done is correct, isn't it? So you come down to the like there is like a lab exam. There's a lab exam you have done something, and you always say that जो मैंने किया था वो सही है. हाँ, you might say that the question is wrong, but जो मैंने किया था वो सही है, because I always do correctly. People always have got a thought process. तो यहाँ पर ये कैसे possible होगा? How do I actually talk whether it is efficient, whether it is not efficient? Like for example, I'll take up some simple example which probably you can understand. Again, a bit different. When we start with the module like a database, there was story was different because database was like something entirely new to everyone. So like what exactly database is, so probably from there we need to start, and then we need to discuss from there step by step till advanced topic. But when it come down to the like module like data structure, we understand that I understand that it is a kind of a prerequisite of a course. So some basic data structures you already know, you already aware of, and forget you people recently you people learn Java, so you might have even revised some of the basic concepts. So obviously I will keep that in mind when I'm delivering this presentation. So see to it that you also keep it in mind and retrieve it as early as possible. That will be really great. So coming back to the point. So you say that, sir, I'm creating an array of 10 elements. So what is efficient? So my array is taking for 40 bytes is efficient, or is it taking 20 bytes is efficient, or is it taking 10 bytes is efficient? Now you people understand it very well that array may take 40 bytes, array may take 20 bytes, array may take 10 bytes. Array of 10 element, the same array of 10 elements may take the different size depending on. Can you just complete the statement? I said it may take different time. Yes, it depends on your data types. Absolutely. So somewhere someone is saying that कि I'm creating an array of integers. So 4 byte का integer होगा, it will take 40 bytes. अगर 2 byte का short variable होगा, it will take 20 bytes. अगर character variable होगा, probably it will take the 10 bytes itself. So what all the point that I want to make it over here is that it is very much dependent on a requirement. You cannot say that, sir, I created an array of 10 elements, so my array is efficient than probably your array, because your array is taking 20 bytes and my array is taking 40 bytes. The problem over is that you might be trying to solve a problem where the short variables are sufficient, and I might be solving such a problem where I need a kind of integer variables. So that is not really the measure that how many bytes it take to store. Number one. The secondly, not only about this, there is something, architecture specific stuff is also there. So sometimes you might have seen that, some architecture size of int is different and another architecture size of int is different. Like right now we are like, x86 platform, we find that size of int is 32-bit. But the same thing you do like a older 8086, or for that sake 80186 or 80286 machines, at that time size of integer was 2 byte. Or probably you go on like an embedded platform like AVR, size of int comes out to be 2 byte. So what I'm saying is that even though by saying you say that it is like an integer, कहने के लिए वो int है, लेकिन that again might have the architectural dependency. I hope you realize the problem, that you cannot always count the efficiency of storage based on based on how many bytes that you occupied. And the same is the problem with the time as well. Let's say that I always say that, like for example, a certain algorithm, let's say that XYZ algorithm running on my machine is taking let's say 10 millisecond. But probably another algorithm that you are running on your machine, the for doing similar thing, let's say one sorting algorithm I'm running on my machine, it is taking 10 millisecond. But the same sorting algorithm, probably you have developed some different sorting algorithm and it is taking 15 millisecond. So do you believe that the 10 millisecond is faster one? I repeat, one algorithm is running with the 10 millisecond time. The second algorithm for similar sort of data, similar amount of data, probably it is taking 15 millisecond. So can you say that 10 millisecond is efficient one? Do you believe that? Yes, you can say that. Oh, how come? Because what I'm saying is that the machine that I'm using is kind of Core i7 machine, and the other person, the machine that he is using, probably the Pentium machine. Is it possible? And now in this particular case, I hope now you visualize that. So on paper, or probably by looking at time, you can say that sir 10 millisecond is faster and 15 millisecond is slower. वो ठीक है, on paper you can say, but what about the architecture on which the execution is done? What about the like computer type that you are using? So like someone is using a machine of let's say 1.5 lakh, someone is using a machine of let's say 10,000 rupees. Again, it's not only architecture dependent, it is also even the machine configuration dependent. Whatever I was discussing right now, whether it is about space, whether it is about space, whether it was about time. This kind of analysis, you will refer it as this kind of analysis, you always efficiency का ये जो analysis है, this analysis you always say that exact analysis. This is exact analysis. And then you ask the question, so what do you mean by exact analysis? The exact analysis of a space, probably you can talk in terms of how many bytes that you are taking for executing certain algorithm or storing that kind of data. And the second one, where you talk about the time, machine time, or the number of CPU cycles, you can say millisecond or microsecond or something like that. So you're talking in that terms. This is referred as the exact analysis. But this exact analysis, most of the time it has been observed that it is useless. Why it is useless? The exact analysis is found to be useless. Why it is useless? Because the things will change from architecture to architecture. Things will change from machine configuration to machine configuration. तो सर कोई solution है? The solution is that exact analysis जहां पर काम नहीं करता, we always go for something called as a asymptotic analysis. Asymptotic analysis. Now where you always talk about, when you always talk about, now how many bytes, nahi, I'm saying that over here we will talk about, let's say, unit space. We will talk about the unit space required for the storage. We do not talk in terms of bytes. Or for that sake asymptotic analysis for the time. So I'm talking about usually how many iterations in this is how many times the loop is getting repeated. I'm talking about asymptotic analysis. So we have got like a exact analysis or asymptotic analysis. So you need to understand that usually when it comes to data structure, we always discuss about the asymptotic analysis. We do not discuss about the exact analysis. Is one. So, sir, what basically asymptotic analysis is, how it goes, and etc. etc. Let us take a look at. The very first thing, yes, obviously we want to talk about is the space complexity first, and after that we will take a look at what is time complexity. So, what is space complexity? It is space complexity. I can say that it is a unit space required to store the data and the additional space required to process the data. So usually when it comes down to the space complexity, there are two components involved. Please make a note of that. The first component I say is the input space, and second thing is, let's say, auxiliary space. I'll give you example. I'll give you example. Suppose that you want to calculate the factorial. You want to calculate the factorial. A very simple, stupid example, I know. So you want to calculate the factorial. To calculate the factorial, what do you need? You need a number. Now you need a number. To store that number, you need some space. So that space you can say like an input space. But the second thing, to calculate the factorial, I guess you need some extra variables to occupy the result, some extra variable to go through the loops. So जब आप लोग कोई extra variable use करते हो, कि loop variable, a result variable, or something like that, I said that it is an auxiliary space. It is an auxiliary space. So we have got like an input space, and the extra variables that we might need during the processing, I call it as auxiliary space. So you call it as a space complexity. You continue further. You continue further. So what is different space complexity? Mechanisms are there. I can say that it's like a O1, ON, ON square. So what exactly O? How do we read it? I can simply say that it is something called as a order of. Technically, it is called as a big O notation, but I always say that it is read it as like a order of. The order of either you say order of n, or you say order of n square, or sometimes you say order of 1. So what do you mean by order of 1? The order of 1 simply means it is a constant. It is not changing with respect to something. I'm hoping that factorial program you can imagine on yourself. And if you're imagining a factorial program by yourself, you can always say that अगर मैं normal loop लिख के अगर मैं factorial calculate कर रहा हूँ, then in that particular case, the what is input space is like one integer. So that space is required. Usually जब हम लोग space complexity की बात करते हैं, we are like more bothered about auxiliary space, the extra variables that we need. So don't you think that अगर मुझको 5 का फैक्टोरियल निकालना है, मुझको 10 का फैक्टोरियल निकालना है, या मुझको 10,000 का फैक्टोरियल निकालना है, आपको फैक्टोरियल चाहे जिस किसी नंबर का निकालना है, you will always find that the loop variable, you need one loop variable, you need one result variable, that's it. Now it is irrespective of कि फैक्टोरियल आप लोग छोटे नंबर का निकाल रहे हो, बड़े नंबर का निकाल रहे हो, बहुत बड़े नंबर का निकाल रहे हो, I would say that the extra space extra space that is required is going to be the constant. It is going to be the constant. So you say that in that particular case, your auxiliary space for the factorial is kind of O of 1. It is not changing. It is not changing with respect to the number whose factorial you want to calculate. But I'm very sure if you ever think of factorial using recursion, now factorial using recursion when you're doing, uh, definitely we will go ahead, we will learn recursion once again. At that time I will explain, but just for time being, you can just relate if you already know. So you might have heard that whenever you are trying to call a factorial of 4, a function activation record or stack frame is created for the factorial of 4, which is internally calling kind of factorial of 3, which is internally calling factorial of 2, which is calling like a factorial of 1, which is calling, let's say, factorial of 0. What is happening? The number for which you are trying to call the factorial, those many function calls are made. And if those many function calls are made, if those many function calls are made, with those function calls will take some space occupied onto the stack. Oh yes, it will take some space occupied onto the stack. I'm talking about that. So you go back. So in this particular case, the space complexity, the space required is probably proportional to n, as the more bigger number you are trying to calculate, the more function activation records need to be created on a stack. So जितना बड़ा number होगा, उतनी ज़्यादा जगह आपको stack के ऊपर लगने वाली है. I can say that in this particular case, that not really time, I should say that space is proportional to n. And if the space is proportional to n, we can say that it is of order of n. और फॉर दैट सेक आगे जाके हम लोग अलग से पढ़ने वाले मोस्ट कॉमन एग्जांपल अ ग्राफ. You try to create a graph of, let's say, v vertices. To create a graph of v vertices, we say that we need to create a matrix. We need to create a matrix of v by v matrix. You are creating a matrix of v by v matrix, so you can say that the space is proportional to n, where let's say n, sorry, space is proportional to n square, where n is number of vertices. In that particular case, क्योंकि वो matrix है ना, a 2D array, 2D array, it is n by n array. So obviously the space required is of order of n square. So this is like pretty simple. What I'm trying to say that like a order of. So here you are not talking in terms of how many bytes. Are we talking in terms of bytes? No, not at all. We are not talking in terms of bytes, but we are talking in proportion to some factor, either the number whose factorial you want to calculate, or the number of vertices, or number of edges, or let's say height of a tree, or for that sake whatever it could be, correct, or number of elements in an array. So with respect to something, you are trying to tell the proportion, how much space it is going to occupy. So that is called a space complexity. But then you continue further, look at time complexity. The time complexity, where we say that the unit time required to complete any algorithm, we are not talking about how many millisecond or how many microsecond or how many nanoseconds are required, because those will change heavily depending on your computer, depending on configuration of your computer, depending on architecture of your computer. So I do not want to talk about that. So what exactly it is, it is usually you say that it is approximate measure of time required to complete any algorithm, wait for a minute, what is that, based on some factor, with respect to some factor. So whatever time that we are talking about, we are always saying that it is a time with respect to something, the time with respect to something. So with respect to this, with respect to that, whatever you said, but it is with respect to something. As I told you, it could be like how many elements in an array, It could be how many elements are there in linked list. It could be what is the height of a tree. It could be how many vertices and edges that you have got, whatever. So it depends on the data structure. It depends on the, what values that you are trying to find out. But you need to find out the proportion कि कौन सी चीज, कौन सा फैक्टर ग्रो हो रहा है, तो करस्पॉन्डिंग उसका टाइम के ऊपर क्या असर पड़ेगा. दैट स्टडी is referred as a time complexity. If you are like absolute beginner, usual mistake that we always do is that we always consider that this many millisecond is better than these many milliseconds, but that is just a time. Here we are not at all finding how much time is there. Rather we are trying to find out कि time required will depend on which factor, and then in which proportion the time will change. Like I'll give you example. तो सर ये mainly किसके ऊपर decide होता है? अगेन कोई 100% और लाइक रिटर्न रूल नहीं है, बट वी कैन ऑलवेज से दैट द टाइम रिक्वायर्ड इज प्रोपोर्शनल टू द नंबर ऑफ इटरेशंस दैट आर कैरिड आउट. इटरेशंस, कितनी बार आपका लूप रिपीट हुआ, कितनी बार आपका लूप रिपीट हुआ है, उसके ऊपर डिपेंड करता है. एंड दैट इज व्हाई यू से दैट द टाइम कॉम्प्लेक्सिटी ऑफ एनी एल्गोरिथम डिपेंड्स ऑन, time complexity of any algorithm depends on the number of iterations in that algorithm. So number of iterations are more, you say that the time required is more. Number of iterations are less, you say that time required is less. It is that simple. So you just continue further. Like again the common time complexities and its general significance I'm trying to tell you. वैसे भी जब हम लोग थोड़ा आगे जाएंगे, जब हम लोग एल्गोरिथम लिखेंगे, लेट्स से बाइनरी सर्च लिखेंगे, लिनियर सर्च लिखेंगे, सिलेक्शन सॉर्ट लिखेंगे, बबल सॉर्ट लिखेंगे, तो हम लोग वापस से इसके ऊपर फिर से सोचेंगे कि ये कैसे करना है. बट ओवरव्यू और काइंड ऑफ रफ आइडिया आई वांट टू जस्ट गिव यू ओवर हियर. द टाइम कॉम्प्लेक्सिटी, द मोस्ट कॉमन टाइम कॉम्प्लेक्सिटीज जितने मैंने यहाँ पर लिस्ट किए, ट्रस्ट मी अपने पूरे मॉड्यूल में इसके अलावा कुछ और आप लोग नहीं देखने वाले हो. सो अल्टीमेटली एज यू प्रोग्रेस विद द मॉड्यूल, मॉड्यूल में जितने सारे टाइम कॉम्प्लेक्सिटीज हर एक एल्गोरिथम के आने वाले हैं, so almost all I have just taken up except few of graph because they are kind of combinations. The very first, a O of 1. What is O of 1? O of 1, I said that the time is a constant time. The time required is a constant time. It is not dependent on any factor, any factor. So whether you are searching in 10 elements, whether you are searching in 10,000 elements, when you say that the time is going to remain same, the time complexity is said to be O of 1. Okay, that is good. O of n, O of n, the time required is proportional to n. Now when I say time required is proportional to n, again you take an example of a factorial program itself. जब लोग factorial program लेते हो तो क्या होता है? In a factorial program, what happens? You write a loop for I is equal to 1, I is less than or equal to n, I plus plus, result is equal to result into I. But your loop is going to run how many times? Depends on a value of n. So if your value of n is 10, the loop is repeated 10 times. If value of n is let's say 1000, then it is going to repeat for 1000 times. And if the value of loop is let's say 1 million, it will repeat 1 million times. What exactly I want to say? I want to say that the bigger is the number, more is the time it will take. More is the time that it will take. So here it depends on the number whose factorial you want to calculate. And whenever you see that it is O of n, usually again मैं फिर से बता रहा हूँ, मैं कोई hard coded rules आपको नहीं बता रहा हूँ, but I'm just trying to tell you the general observations. These are the general observations. Usually that will a program involves a single loop. So most of the cases you will find that अगर आपके प्रोग्राम में single loop है, then it will be like O of n. Okay, that is good. I'll just continue further. Then going ahead, it is O(n) square. What is O(n) square? You are saying that the time required is proportional to n square. So any example? A typical algorithm, selection sort, bubble sort, what is that? These sorting algorithms, they all will be coming like a O(n) square. O(n) square is a typical example. I would say that it is a nested loops. Nested loops in the sense I'm saying loops inside loops. And how many nested loops? I would say that two nested loops, one within another. You can say that it is O(n) square. जब हम लोग सिलेक्शन सॉर्ट बबल सॉर्ट का कैलकुलेशन मैं आपको बताऊंगा, आपको समझ में आ जाएगा. जब लूप के अंदर लूप होता है, मीनिंग आई एम सेइंग दैट इनर लूप के इटरेशंस, inner loop is repeated each time for the outer loop. So outer loop के हर एक iteration के लिए, outer loop के हर एक iteration के लिए inner loop के सारे iterations होते हैं. आउटर लूप के हर एक इटरेशन के लिए इनर लूप के सारे इटरेशंस होते हैं, तब हम लोग कहते हैं इट इज ओ एन स्क्वायर. Okay, that is good. Then what is O n cube? O n cube, that you can see it is where again it is a nested loops, but it is now loop within loop within loop. So there are three loops back to back. A three loops back to back, you can say that it is O n cube. So do you know any algorithm? Yes, I know the algorithm. That is the only reason I have written there. Warshall Floyd algorithm. ये बहुत time है. Probably on the last day we will talk about that. But Warshall Floyd algorithm is typically a graph algorithm. And the graph algorithm, yes, it will take three loops, I, source and destination. और ये तीन loops एक के नीचे एक जब रन होता है, the time complexity is like O n cube. Now you go ahead. Let's say O of log n. What is O of log n? You are saying that the time required is proportional to log. But again, you ask the question, how you can say that it is proportional to log? I'll give you some example. A typical example where the partitioning is involved. Your whole array, you are trying to array, not necessarily array. You talk about any example जहां पर division होता है, जहां पर division होता है, तो जहां जहां पर division होता है वहां वहां पर partitioning is involved. I'll give you some simple program. Write a program to convert like a decimal to binary. अगर आपने कभी decimal to binary conversion किया है using not using bitwise operators, using kind of a division method, what we call a double double method. I hope you must have heard of it. You take a number, you divide, you record the remainder. Again, whatever is the result, again you divide by 2, again you record the remainder, and again you divide by 2, again you record the remainder, and you go in like a reverse way. So वो जो कुछ भी आप लोग कैलकुलेट करते हो, यहाँ पर हम लोग क्या कर रहे हैं? Whatever number that we have got, we are dividing by 2, dividing by 2, divide by 2, divide by 2, and we are trying to reach to the zero. So जहां जहां पर हम लोग ऐसा करते हैं, so जहां जहां पर जिस किसी कोड में कहीं पर आपको पार्टीशनिंग दिखेगा, there are likely chances are that the log factor is involved. The log factor is involved. Yes, binary search is the best example where you can find that the log n you can see. Don't worry, binary search वैसे भी हम लोग आज ही पढ़ने वाले हैं, so you will be able to compare and you will be able to appreciate that as well. Going ahead, O n log n. What is n log n? I said that the time required is now proportional to n log n. Now, what is this? In this particular case, again, log n factor is talking about partitioning, but the partitioning is also repeated. It is not one-time partitioning. If it is like one-time partitioning, that is fine. Then you say log n. But if it is partitioning is done each time, then you go for n log n. And the again best example would be quick sort, merge sort, or kind of heap sort, where the time complexity comes out to be O of n log n. I'll take up one two problems. As I said that the algorithm की requirement ही है, अपने model की requirement ही है कि we should be able to think a little. We should be able to think a little. So I will just ask you for some problems. I'm not expecting that you people write a code. I'm very sure you must have written a code sometimes somewhere, and then recalling that, if you could tell me what could be the time complexity, that will be great. Like one, let's say for example, I'm just going ahead. I'm just going ahead. The first one, check if number is prime. Check if number is prime. I'm not looking for the efficient implementation. I'm looking for a normal implementation. No efficient implementation. I'm not looking for any kind of efficient implementation. Yes, the time complexity will be O of n. Why time complexity is O of n? Because reason is very simple. Typically the loop that we write is something like this. For I is equal to 2, I is less than n, I plus plus. And inside that we check if n mod by 2 is equal to 0, then we simply say that this is not prime. This is not prime. Otherwise, we can say that it is prime. Something like this. Yes, such kind of simple implementation we might consider, isn't it? Yes, absolutely. So I'm saying that in this particular case, what is important? What is important? You take a look at, oh sorry, my mistake, not mod by, ये even number check करने का part है. Yes, I got it. It should be n mod by I. So आप लोग क्या कर रहे हो, 2 से लेके हर एक नंबर तक, A2 से लेके हर एक नंबर तक आप लोग डिवाइड करके देख रहे हो. If it is divisible till number minus 1, 2 to that number minus 1, anywhere you find it divisible, you say that it is not prime number. But if it is not divisible by any of that, then you say it is a prime number. Absolutely there. What is important over here is a loop. And this loop, number of iterations are dependent on, a number of iterations dependent on value of n. So as your n grows, the number of iteration grows in the same proportion. So I can say that the time complexity over here should be considered as O of n. I'll take up like one more example. One more example, let's say find all combinations of A, A, B, and C. So given three characters, I want to find out all possible combinations. Let's say ABC, ACB, or whatever. So what do you need? I guess typically you need to run 3 loops, isn't it? Yes, you need to write 3 loops. And if you are writing 3 loops, you always say that it could be then in this case ON cube. So I'm saying that it is 3 nested loops that you can use. And the 3 nested loops, it will say that time complexity should be ON cube. But I repeat, ऐसा कोई जरूरी नहीं है कि एक लूप दिखे तो O ऑफ n, 2 लूप दिखे तो ओ एन स्क्वायर, 3 लूप दिखे तो ओ एन क्यूब. इसको रूल मत बना लेना. सोचना, एक्चुअल नंबर ऑफ इटरेशंस, आर दे रियली चेंजिंग with respect to something, or they are going to remain same. So before you answer, before you come up with the conclusion कि इसका टाइम कॉम्प्लेक्सिटी यही होने वाला है, यहाँ पर अभी हम लोग क्या सोच रहे हैं सर, यहाँ पर आपने ओ एन क्यूब, यू आर सेइंग दैट because it is like taking 3 nested loops. Yes, A, B, C. आप लोग कह तो रहे हो, but as I said that, let's say for example A, B, C, D. अगर आपको 4 निकालना है, then probably there will be 4 nested loops. अगर आपको 5 का निकालना है, there will be a 5 nested loop. But as long as you are changing, सर मुझको ABC नहीं करना है, मुझको XYZ करना है, सर मुझको XYZ नहीं करना है, मुझको PQR करना है. Now you will find that it is not really changing with respect to, it is not changing with respect to how, which characters that you're using. It is changing how many characters are there. You please keep this in mind. So before you answer, you need to always say, okay, what exactly is it really changing? आपने cross check करना चाहिए. I'll take a one more example and then we will move on to the actual work. And I want you people to think a little. I want you people to think around this and then answer me, because this is a bit tricky. This is a bit tricky. So print table of n. A table मतलब 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 tens are 20. This is what you call it as a table. So given number का table print करना है. So what do you believe? What is the time complexity? मैंने कहा सोच के बताना जवाब. Yes, that is good. Like people are thinking, and many of them are thinking. So that is really good sign. I say that time complexity will be O of 1. Now you ask the question, sir, O of 1 कैसे? Loop तो है ना? अरे loop है, लेकिन is it dependent on any factor? You always know that your loop will be something like this. For I is equal to 1, I is less than or equal to 10, I plus plus, I plus plus, and simply you want to print number into I. This is what all you're doing. So आपका n चाहे 1 हो, आपका n चाहे 100 हो, चाहे आपका n 1000 हो, is it going to make a change into the number of iterations? Not really. And if it is not going to make a change in the number of iteration, you should not blindly just say that the time complexity is, let's say, O of n. अगर आप लोग blindly कह रहे हो, then it is very dangerous. I hope you got the point. And this is something that I'm trying to tell you always कि time complexity मैंने आपको rough ideas दिए, मैंने आपको examples दिए. What is more important is that You should always, once you can just guess something, no doubt on that, but after you guess, you should at least think logically, क्या सचमुच एन चेंज होने से ये बदलने वाला है? अगर बदलने वाला है then it is okay. अगर नहीं बदलने वाला है, इसका मतलब you need to rethink on it, right? So going ahead. तो सर ये जो आपने यूज किया, you say that it is order of, or you call it as let's say big O note, sorry, order of, or you call it let's say big O notation. So do you believe that that is the only notation available or not really? Huh, so is it only available or not really? So you find that big O is kind of one notation, but apart from that, there is another notation called as omega notation, and there's also notation called as let's say theta notation. So what these notations are all about, and why the multiple notations are there? To be frank, there's a lot of mathematical jargon behind it, but to keep it simple, the big O notation talks about the upper bound, or you can say that how much time maximum it will take to run this algorithm. One talks about lower bound, how much is like a minimum time that it will take to run the algorithm, and where theta, where you try to be bit more precise, what is the maximum and what is the minimum time, correct? So upper bound, you talk about the maximum. अगर आप लोग time complexity की बात कर रहे हो, then I can say that like a maximum time, maximum running time. This one is talking about like a minimum time, right? And this one you can talk about like the regular time, or you can say it's kind of an average time, right? The maximum time, this is not 100% connected, but still you consider, to keep it simple, that maximum time you can call it as kind of let's say worst case, usually corresponds to the worst case, that how much maximum time it will take, or like a best case, how much like a minimum time it will take, and the average time, where we can say that it is the average case, or like in general case, how much time it will take. Obviously we will see with some of the examples, but you need to just correlate them. Ki there is like a big O notation, omega notation, and theta notation as well. तो सर ये बहुत हो गया. We have talked about lot of theory. What is data structure? We talked about efficiency of data structures. We talk about like a space complexity करके कुछ तो होता है, time complexity करके कुछ तो होता है. But you know it becomes too boring just to keep listening to this. Why not we go ahead and we start talking about algorithm, and not only writing algorithm, but yes, we will talk about efficiency as well. Let me tell you the method of teaching that I'm going to follow. If you have any objections, let me know immediately. So my method of teaching is very simple. I'll first focus on algorithm. I first focus on algorithm, understanding what the algorithm is, what is the idea behind algorithm, how the algorithm actually go, and we will be focusing on paper how this algorithm should run. On paper how this algorithm should run. I'm expecting अगर आप लोग डेटा स्ट्रक्चर जैसा मॉड्यूल पढ़ रहे हो, you should have a notebook beside you, with the pencil, eraser, pen, whatever that you need, you should be having with you. अगर आपको ज़्यादा better output चाहिए तो, if you are just in listeners mode, there are likely chances that you will find it most troublesome module, because after that you will be in a question, सर इतने algorithm आपने पढ़ा है, हम इसको सर याद कैसे रखेंगे? Algorithms are not to be by-hearted. Algorithms are to be understood. The algorithms, need to be confirmed. क्या ये जो algorithm सर ने बताया is the same algorithm? तो सर how do we do confirmation? There are 2-3 rounds of confirmation. जो बता रहा हूँ उसको ठीक से सुनो, so that we are like क्या कहते हैं उसको, in sync. हाँ, the very first thing I'm saying that ideally I should be showing algorithm with you. यहाँ पर मैं आपको algorithm बता रहा हूँ. One time, two time, three times, you say as many times, we can definitely repeat on algorithm. There is absolutely no problem. But just by listening the algorithm, you will never be comfortable. At the same time, you should do it by yourself as well. So like taking a similar example, you try it on paper. As you try it on paper, you find that yes, it is going good. That is second step. Third step, ideally, you should be logged on your system, And if you're locked down in your system, on your computer, ideally you should copy paste the code and run it with me. कोड शेयरिंग मैंने ऑलरेडी चालू कर दिया है, सो आपने ऑलरेडी उसको कॉपी करना चाहिए और आपने उसको एग्जीक्यूट करना चाहिए. दिस इज लाइक अ थर्ड थिंग. बट वेट, फोर्थ थिंग. तो सर इतना करके हो जाएगा कॉपी पेस्ट से? टू बी फ्रैंक, सम सिंपल एल्गोरिथम्स लाइक लीनियर सर्च, सिलेक्शन सॉर्ट, बबल सॉर्ट, आपने इससे पहले भी कभी ना कभी किए होंगे, तो यहाँ पर ये काइंड ऑफ रिवीजन हो जाएगा. दैट इज फाइन. कॉपी पेस्ट कर रहे हो, वर्क हो रहा है, दैट इज वेरी गुड. बट आफ्टर दैट, when you go to the lab, what you should be doing? When you go to the lab, I again recommend that you should again do the paperwork. Whatever algorithm that you have learned, why don't you try it on paper once again? You try it on paper once again. You try to, already code will be shared, no doubt on that. You can try to build the code once again by yourself and then type the code on your own. I repeat, for the simple algorithm, you need not to waste your time. Rather, I recommend for the stupid algorithm, you should not spend your time. The algorithms which need more time, algorithm like you learn quick sort, merge sort, it will take its own time. So you spending, at least 1.5 hour on quick sort, 1.5 hour on merge sort, it is necessary. You spending, I'm not saying that I spending. मैं तो यहाँ पर क्लासरूम में पढ़ाने ही वाला हूँ. I'm saying that your own time with paperwork and actual typing will give you more confidence than just listening or just copy pasting. So while the lecture is going on, you can copy paste with me, but when you go to the lab, these kind of stuff you should type by yourself. Apart from that, I have planned some of the assignments for you. Now the assignments are usually kind of application oriented. So whatever that algorithm that you learn, like a basic algorithm, but how do you put it in practical or like given scenario? So you need to think upon that. I just don't want to make this assignment absolutely compulsory to everyone, because that will change from the student level to student level. And I do not really even want to waste my time into the assignment discussion, because if I spend time on assignment discussion, I will not be able to catch up with your the syllabus that I'm supposed to give it. But assignment still I have planned, because every batch there are some ambitious students. So I want, if you are ambitious enough, you are like done with like a basics, you go ahead and you try to solve those assignments as well. Those assignments should help you more, no doubt. And at the same time, if it is possible, rather make it possible. Now you people are well acquainted with each other. Start working bit groups and subgroups where you can discuss the things once again. You can discuss the things once again. You can discuss the some of the like assignments, not the code I'm talking about. Assignment, ये assignment है, तो यहाँ पर assignment में exactly क्या करना है, what logic is needed. So you can discuss with among yourself and then try to write your own code. Someone is saying that for assignments we always discuss with the lab mentors. Yes, lab mentors will be available, but trust me, you do not discuss with the lab mentors. You get the solutions from the lab mentors. Getting solution from a lab mentor is a different thing, and discussing is a different thing. I hope you are getting the difference. Because I was saying that जब मैंने शुरू किया था, I just started, कुछ लोग late join हुए थे, I guess. I should be saying that the very first intent of this module is to build the thinking abilities. And trust me, thinking ability तब नहीं बढ़ता है when you know the right solution. Thinking ability तब बढ़ता है when you spend your time even on the wrong solutions. When you discuss the ideas, that improves on a thinking ability. Just getting a ready-made solution, sir ये ऐसे है, sir इसमें क्या करना है, तो your faculty says that अब इसमें ये करना है, so you go and implement that, where your thinking ability is improved. When you discuss among each other, you do the bit of, you call it the brainstorming process. That brainstorming process is somewhere required अगर आपको आपके thinking abilities को improve करना है. तो I suggest definitely lab faculties are available and you should be definitely talking to them as well. But this will give you the better idea of the module or why data structure is to be learned, right? So I hope you got the point. Anyway, चलो अब मैं आगे बढ़ रहा हूँ. What I'm trying to tell you is that मैं कहाँ पर था? हाँ, लीनियर सर्च. तो मैंने आपको आइडिया बता दिया. हम लोग एल्गोरिथम कैसे पढ़ने वाले हैं. हम लोग पहले एल्गोरिथम ऑन पेपर पढ़ेंगे. We will try to ensure that कि algorithm clear हो गया. And once you say that algorithm is clear, then I will go on to the code front. I will go on a code front and then I will type a code in front of you. We will compile it, we will run it. At the end, you can copy paste the code, you can execute by yourself and see that, oh yes, it is working. And if the code is big enough, please go ahead and what is that? Please go ahead and क्या कहते हैं, type it once again. Linear search is very stupid one. You need not to. Someone is saying that code sharing is not working or portal is working very slow. Is it so? No idea. वैसे टू बी फ्रैंक मैंने अभी तक कुछ शेयर किया ही नहीं है. अच्छा, नॉट लॉगिंग इन. अच्छा, अनेबल टू लॉग इन. ओके 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 ओके. हाँ, so it understood. I look like नहीं, there might be some issue at the internet end as well, but there can be, देखो कुछ लोगों का it is working, कुछ लोगों का it is not working. Anyway, control F5. Yes, Pranali gives some solution. Okay. I see, the varieties. So few people not working, few people are working, and few people are like different. Anyway, we can do one thing. वैसे immediately नहीं लगने वाला है. You first find out, and if you at all need, don't worry. Listen. We will do on a multiple ends as well. Absolute no issues. I will also copy it into this. Whatever the file is created, I will take care. Just give me the reminder. And I will also copy it into the Zoom chat. So I will copy the whole file so that you can just take it from there. So we will work out on the mechanism. एक चीज अच्छी है डेटा स्ट्रक्चर के मॉड्यूल में कि हमें कोई बहुत बड़े बड़े क्या कहते हैं उसको, बड़े बड़े कोड नहीं करने. So we will find out some alternative, and parallelly definitely I'll also check with the backend team whether any checks are to be needed onto the software front as well. Anyway, that we can do it on a parallel. चलो अभी हम लोग आगे जाते हैं. Let us not waste too much of time. हम लोग कहाँ पर थे? So let us get started with the algorithm first. Linear search. अब इससे simple algorithm तो वैसे भी हो नहीं सकता. What is linear search algorithm? The linear search is that you have got list of elements. When I say list of element, it could be array, it could be linked list, or whatever you said. So linear search simply means that you start accessing the elements one by one and you compare whether it is matching the given number or not. So find a number in a list of given numbers, and the numbers may not be in a sorted order. The numbers might be in an unsorted one. So anything, I really don't know. So what is to be done? I'm just going ahead and like one by one. The very first, what I can do, I can take a simple loop variable. And I can begin comparing. Let's say, for example, I want to search element 22. This is, let's say, element that I want to search. This is the element that I want to search. How do I start? I start with I is equal to 0. Take a look at this. I is equal to 0. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. I plus plus. Is it matching 77? Not really. Is it matching 77? Yes, I found that this is matching 77. And if this is matching 77, whatever, either you return the address of that element, you return the pointer to that element, you return the index to that element, that is up to you, depending on a programming language that you have chosen. What linear search says? The linear search simply says that you start from the first element and you go step by step. You start from the first element and then you go step by step, till the element, that you found. This is what you call a linear search. So इसमें कोई बहुत बड़ा explanation or like heavy programming नहीं है. हाँ, but there are definitely some of the special cases that I want to consider. Like one special case, the element that you are searching, listen carefully, the element that you are searching, let's say you are trying to find out 88. Don't you think that the element that you are searching is available right there? The first iteration itself, I found the element. What is this? This is where you need the minimum number of iterations. And if this is where you need the minimum number of iterations, I can say that it is best case. So best case where you need the minimum number of iterations. Minimum number of iterations, you say is the best case. Again, please think more what is that, rationally. You have got array of 10 elements. Element that you are trying to search is the first element. How many iterations that you need? I need only one iteration. Let's say I have got an array of 1000 elements. I got an array of 1000 element. The element that I'm trying to searching is still first element. How many iterations I need? Oh, still again it need one. Again, I got an array of 1 million elements, but the element that I'm searching is still the first element. Still the first element. What you see over there? What you see over there? The time required is not dependent how big your array is. The time required in this particular case, a time required in this particular case, you can say is a constant time. Why it is constant time? So you find that only one iteration, irrespective of how huge your array is. And when is the time required is constant, I can say that it is O of 1, or you can even say it is kind of omega of 1. अब O of 1 को या फिर omega of 1 को, but then omega is something that I was trying to tell you कि वो minimum इसके लिए usually consider किया जाता है. Usually as I say that the practically जब भी हम लोग काम करते हैं, जब लोग कंपनी में जाओगे, अगर if at all you work at the level of like performance tuning of the algorithm, at that time usually we do not bother about like what is omega and what is theta and etc etc. We only talk about like a big O notation only, and with the big O notation you say it's the O of 1. O of 1 seems to be a best case, but then what could be the worst case? The worst case is probably you are trying to find an element, you are trying to find an element which is either a last element or the element not found. Let's say for example, in this particular case, oh, my mistake. Now you continue further, and let's say that you are trying to find out 11. As you are trying to find out 11, and I'm saying that either it is the last element or the element doesn't exist at all. So in this particular case, what I need to do, I need to start I is equal to 0. Is it 11? No. I plus plus? No. I plus plus? Still not 11. I plus plus? Not 11. I plus plus? Not 11. I plus plus not 11, I plus plus not 11, I plus plus not 11, I plus plus, and I found that yes, it is 11. So I found the element is found over there. So here you need to go through all the iterations where I can talk about like a maximum iterations. So in which case you need the maximum iterations? In which case we need the maximum iterations? There are two possibilities. ये two possibilities, या तो element not found है या फिर last element आप लोग search कर रहे हो. In either case it is going to take n iterations. So in this particular case अगर आपका 10 का array है, 10 का array तो ज्यादा से ज्यादा 10 iterations. अगर 100 का array है तो ज्यादा से ज्यादा 100 iterations, और अगर 1000 का array है ज्यादा से ज्यादा 1000 iterations. So again max to max, I'm saying that the time required is proportional to n. And if I say time required is proportional to n, you usually say that it is O of n, order of n. जैसे जैसे n grow होता जाएगा, the worst case time may grow. What all you are saying? And then you talk about, but sir, ऐसा कभी होता नहीं है that we are too lucky that you get the element at the first, or we are too unlucky that you always get the element at the end. You know, the real world, there will be a kind of a combination, isn't it? In real world there will be a combination. There will be few times I may get it early, few times I may get it at the end, few times I may get it in between. So the things might change. So if the same experiment I run it again and again, same experiment I run it again and again with the different random numbers, with the different random numbers, there are likely chances are that the time required or the number of iterations required are like varying. Yes, number of iterations might be varying, but if you take, you're running the same algorithm again and again with the random numbers, and you take an average of it, I would say that then you can talk about on an average how many iterations that you need. I can say that on an average, if there are n elements, I can say that n by 2 iterations that I need. By the way, ये proportionality का साइन है. ये proportionality का साइन का मतलब क्या है? यहाँ पर प्रोपोर्शनलिटी में वैसे भी कांस्टेंट कंसीडर नहीं होते। आई होप आपको पता होगा। इवन ऐसे टाइम रिक्वायर्ड इज प्रोपोर्शनल टू n by 2 बिकॉज मैंने एवरेज निकाला ऑन एन एवरेज ऐसे n by 2, बट विद द n by 2 1 by 2 is a constant, and if 1 by 2 is constant, this is ultimately meaning time required is proportional to n, isn't it? And if the time required is still proportional to n, a time required is still proportional to n, I can say that it is theta of n. It is theta of n, or you can say that O of n once again. O of n once again. I'm saying that like a worst case, like a best case, like an average case. So these are three different cases that we are trying to talk about. Hey, by the way, it was about time complexity. What about for the space complexity? Hey, what about space complexity? Hello? What about space complexity? Any idea? The space complexity, again, you talk about two, three things. A first thing, you talk about like an input space. How much is the input space? How much is the input space? बेसिकली पहले आपको एरे तो स्टोर करना चाहिए ना। बेसिकली आपको एरे स्टोर करना चाहिए। अगर एरे 10 एलिमेंट का होगा तो जो साइज लगेगा वो, अगर एरे 100 एलिमेंट का होगा तो जो साइज लगेगा वो, और अगर एरे अगर 1000 एलिमेंट का होगा तो जो साइज लगेगा वो, ऑब्वियसली द साइज इज चेंजिंग with respect to number of elements. I can say that input space is depend on number of elements, and I can say that it is order of n. But what about auxiliary space? Auxiliary space. The auxiliary space is like how many extra variables that you might need to solve this. अगेन अगर आप इसका कोड लिखते हो, कोड इसका बहुत ही स्टूपिड सा कोड है, फॉर i is equal to 0, i is less than n, i plus plus, and then simply you are checking that if it is matching with the key return. So you need only one I as a extra variable, or even though for that sake, even though you count the key to be searched, but it is fixed. Again please understand that it is fixed. अगर आप लोग 100 के एलिमेंट में 100 के एरे में सर्च कर रहे हो या फिर 10,000 के एरे में सर्च कर रहे हो, द नंबर ऑफ वेरिएबल्स दैट यू नीड दे आर नॉट चेंजिंग। आई रिपीट, वेरिएबल के अंदर की वैल्यू बदल सकती है, बट वेरिएबल को स्टोर करने के लिए जो साइज चाहिए, दैट साइज इज नॉट चेंजिंग विथ रिस्पेक्ट टू द नंबर ऑफ एलिमेंट्स, एंड आई कैन से दैट द स्पेस रिक्वायर्ड will be the constant, and if it is constant you can simply say that it is O of 1. But sir, what exactly it needs? There you can write a small code. वैसे जिन लोगों का टाइपिंग अच्छा है, आई डू इवन रिकमेंड दैट इफ इट इज पॉसिबल आप लोग मेरे साथ टाइप करो, मेरे साथ नहीं, इनफैक्ट मेरे से पहले टाइप करो, बिकॉज इट यूजुअली हैपेंस दैट आई कीप एक ही एल्गोरिदम में 2-3 बार एक्सप्लेन करता हूँ, और एल्गोरिदम्स कभी-कभी इतने स्टूपिड होते हैं कि वो देख के अच्छा ये ऐसे ही तो करना है, सो यू कैन इवन स्टार्ट बिल्डिंग अ लॉजिक बाय योरसेल्फ। यू नीड नॉट टू इवन वेट कि सर कब करेंगे, फिर हम लोग सर का कॉपी पेस्ट करेंगे, ये करने की कोई जरूरत नहीं है, ये करने की कोई जरूरत नहीं। सो आई एम जस्ट गोइंग अहेड, और मैं आपको क्या बता रहा था, द टाइम हाउ डू यू राइट अ कोड, इट इज वेरी इजी। फॉर i is equal to 0, I is less than n, I plus plus, all I need to do is that if array of I is equal to the element to be searched, अब जावा में पॉइंटर्स नहीं होते तो आई कैन रिटर्न ओनली द इंडेक्स, आई कैन रिटर्न ओनली द इंडेक्स, बट इफ इट इज नॉट देयर, if it is not matching, then I can say return -1. Why -1? Why not 0? A 0 itself is a valid index. So I'm just saying that if the element is found, if the element is found, return index. Return index if found. Return -1 if not found. Correct? So that kind of simple logic we are trying to build. I guess we can go ahead, we can type quickly, we can run, and then we can go ahead. So you just talk about create a Java project. I'm very sure आप लोग expert हो Java के program project बनाने में, and then I can go ahead, let's say searching. Next, आप लोग भी आई होप आप लोगों ने Eclipse ओपन कर लिया है, और Eclipse ओपन करने के बाद में आप उसके ऊपर Now it is dealing with Spring. इसको अचानक से Spring की कुछ तो याद आई लगता है. Some of the Spring tools it is updating behind the scene. Let me check whether the internet is stable. Look like. I'll wait a little, otherwise I will. वैसे आप लोग चिंता मत करो. द थिंग इज दैट आई हैव जस्ट बिट ऑफ. मेरा इक्लिप्स जो है वो लेटेस्ट इक्लिप्स है. 2020 9th or that third quarter. So that has been there. So it might be कुछ अलग फीचर आपको दिखाएगा, but it should not be a big deal. So I'm writing, let's say, searching me. All right, this looks good. And we have got like a main. All right, I found this. And let us get started. I'll start writing a method. Let's say linear search. Okay, that is good. You take the array, and not only you take the array, you also look for which is the element that you want to search. How do you write this? As I said that it should be very simple. For integer I is equal to 0, I is less than array dot length I plus plus. If array of I is equal to key, I found the element, you simply say return I. Otherwise, return -1. Correct? So here मैं यहाँ पर क्यों लिख रहा हूँ, मैंने ऑलरेडी वहां पर लिखा हुआ है. That's it. If the element is matching, return the index. Otherwise, return -1. How do you call this? Go ahead, declare an array. By the way, we are here to learn data structure, not Java. जो कुछ भी जावा आपने ऑलरेडी पढ़ा हुआ है, you can always recall it back and you can always work on that. I have designed some of the assignments which will help you to go back and recall your Java stuff as well. However, I'm not over here wasting too much of time in like how to, what is that, take the input from the user, फिर scanner declare करो, फिर उसको run करो, फिर उसको input user से ले लो. I'm not going to waste my time. You can always go ahead and improve on this flow code. Right now, I'm just taking some array and purposefully I'm taking an array which I have shown it into my diagram. 66, let's say 99, let's say 44, we have got 77, we have got 22, we have 55, and we have got 11. Is my array is there? And then you continue further. You want to search an element. Okay, utna part mein user se le raha hu. How do you search an element? I guess we use something called a scanner. Scanner is equal to new scanner. Okay, this is there. System.in. All right. You continue further. You ask user, okay, enter key or element to search, to find whatever you want to say. It's up to you. And number that you want to search is nothing but how do we take an input is like this. And then you make a call to the function. Let's say linear search, you pass the array, you pass the key. Okay, that is good. What it is going to return me? Yes, it is going to return me the index. Oh, I got the index. And if I got the index, I want to check if index is not equal to -1, I probably want to give a result. What is that? What is that? Key found at index something, you call it as a index. All right. Else you want to give a message that key not found in array, whatever you want to write it, go ahead, write it. That's it. Yes, this is done and nothing more that you need to do beyond this. So इतना ही करना है, absolutely इतना ही करना है, और कुछ भी करने की जरूरत नहीं है. Right? Let's just go ahead and to run the application, run as Java application. Oh, good. It is executed and I'm trying to search 33. Oh, it is found. That is great. You continue further. I want to find out element, let's say 55. Oh, probably it was somewhere at the end, at the index 7. Oh, that is also working. You run it once again. Let's say you try to find out element 20. Oh, it doesn't exist at all. Quite good. I hope things are pretty clear, pretty straightforward. what linear search is, how linear search execute, and so on and so forth. If your code sharing is working, that is great. You can copy it from there. If code sharing is not working, Zoom chat I have already copied. You can take it from there. You can execute it. And as I said that such a simple program, I do recommend that ये program आप लोग जब मैं algorithm explain कर रहा हूँ तभी भी आप लोग type कर सकते हो. There is nothing great in these basic algorithms at least. When it comes down to the advanced algorithm, definitely now you need to pay attention. If someone could complete this, execute this, can give a little confirmation, and then we can go from there. Yes, good. So things are working well. As I say that linear search इस algorithm में कोई भी बहुत दिमाग लगाने वाला या कोई तो बहुत complicated या कोई special algorithm है, ऐसी कोई बात नहीं है. So linear search is like pretty simple. You have understood it, and then we can continue further on to the next algorithm. By the way, just one or two things that I want to ask. Okay. So what I was asking you is that this is hopefully comfortable, and then we can continue further with the like next algorithm called a binary search. So मैं आपको ये पूछ रहा था, what is usually your break time? Let's say break time, the duration I'm asking you. The usual break duration, 15 minutes is good. Okay, no problem, no issues. We will just go ahead. Yeah. वैसे we will go with the majority. So few people can also say that, sir, हमारे लिए we don't need a break. We need only 5 minutes break. So it is up to you. Usually, nearby 11 o'clock, we will have our first break around 15 minutes, and then probably we can have one more break nearby 12 o'clock for the 10 minutes. Right? So don't worry. Chalo, we can go ahead and we can talk about the next algorithm. The next algorithm we are talking about like a binary search. So let us just take a look at the idea what a binary search is. And as I said that this algorithm is bit complicated as compared to linear search, because linear search was not at all complicated. So binary search, we need to think and we need to progress. The very first thing, before you start talking about binary search, let us talk about the requirement of a binary search. The binary search is different than the linear search. And for a special case, what is special case? The binary search is one, listen carefully, the binary search is one where for sorted arrays only. So binary search सिर्फ sorted array के लिए बनाया गया है. Binary search is not designed for the non-sorted array. यहाँ पर अपने example देखा था, I just taken something in random because I know that taking something in random is more than sufficient. However, when it comes down to the binary search cannot be and should not be used with the unsorted array. I'll give you example. Suppose that you have got a book. And let's say that the book binding is a complete mess. The book binding is complete mess. The pages are put in like any order, and then whichever way is like 1,000 page book, and somewhere you want to find out the page number 700. So I said that 1,000 page book, it is completely messed. The binding, the pages are literally in any order, the scattered order, and you are trying to read the page number 700. How do you go? How do you go? I guess you have no option other than checking the page one by one. The first page, second page, third page, fourth page. कहाँ पर 700 page number दिख रहा है? That is the only way that you can find out. However, the other way around, listen carefully, other way around, if the book binding is proper, right? It's 1,000 pages book, but like 1 to 1,000 in a sequence, everything is gone well, and you still want to read the page number 700. You want to read page number 700. How do you read that? Do you go for like a first page, second page, third page? Oh no, even though you have got an index table, Gaurav, Sneha, even though you have got an index table, please understand that इंडेक्स टेबल जब आपके पास होगा तो आप लोग इंडेक्स टेबल में आपको पेज नंबर पता चल रहा है. मैं पूछ रहा हूँ, you know the page number.
आपको उस पेज के ऊपर जाना है. हाउ डू यू ओपन अ बुक? आई गेस यू टेक रफली अप टू सम पेजेस. आई गेस आप लोग ऐसे करते हो. अगर आपके सामने कोई बुक होगा, पढ़ा हुआ होगा विद पेज नंबर, जस्ट ट्राई करो, उसमें से कोई तो पेज नंबर ओपन करने की कोशिश करो. सो यू नेवर स्टार्ट फ्रॉम लाइक अ पेज 1, पेज 2, पेज 3. यू ऑलवेज लाइक, अगेन नॉट नेसेसरी अप्रोक्सीमेटली हाफ ऑलवेज, बट देन ऑन अ रफ यू जस्ट टेक इट लाइक, कुछ अंदाजा लगाते हैं हम लोग, निकालते हैं. लेट्स से आपने कुछ तो अंदाजा निकाला और यू फाउंड दैट इट इज 600 पेज नंबर. व्हाट डू यू डू? You find a 600 page number. So what do you do? Now, where do you check? Do you check before that or you check after that? आई गेस यू अंडरस्टैंड वेरी वेल. अगर 600 है तो 600 के पहले देखने का वैसे भी कोई मतलब नहीं है. हमें जो भी देखना है उसके बाद में ही देखना है. अगेन वापस से 600 से हम लोग ऐसा नहीं करते, चलो अभी 601, 602, 603. नेवर. अगेन वी टेक लाइक अ बंच ऑफ पेजेस वंस अगेन, एंड लेट्स से you found that the pages that you found is like a 750 pages. Up 600 पेज से you jump on to 750. Now what do you do? Now what do you do? Again, अब वापस से 750, you know that 700 आपको ढूंढना है, तो it has to be before. So again you find roughly, you come like a nearby 698 or something like a page number. You reach to the 698, so you find that अब एक दो pages आगे है, that you open it. I hope you got the idea. This is what we do in like a real life, and something that we do in real life. Obviously, we want to do the something similar in a programming as well. तो प्रोग्रामिंग में ये जब किया जाता है, इसको कहा जाता है बाइनरी सर्च. नाउ बीइंग अ ह्यूमन, हम लोग एग्जैक्ट हाफ वगैरह नहीं करते, बट कंप्यूटर इज देयर. कंप्यूटर को आप लोग ये नहीं बता सकते कि अंदाजे से कुछ तो पेज उठाओ. नो, कंप्यूटर डजंट वर्क बाय योर हेयरस्टिक. कंप्यूटर यूजुअली गोज बाय सम डेफिनेट formula, and the definite formula over here is that you divide your array exactly into two parts, and then you divide into two parts, you compare whether the element is matching. If it is matching, well and good. But if it is not matching, the element that you are searching is greater, or element that you are searching is smaller. If it is greater, you focus on a right half. If it is smaller, you focus on a lower half, and again you repeat the same process. Yeah, again you repeat the same process means again whatever that part was there, uska वापस से आप लोग you find out again midpoint, and again you compare. This is a logic behind the algorithm. This is the philosophy behind the algorithm. So पहले जब भी यूजुअली मैं ये जो स्टार्टिंग में आपको फिलोसॉफी बताता हूँ, वहां पर यू मे नॉट फाइंड द होल algorithm clear, but at least you get the core idea of the algorithm. So you should never miss that, so that you remember this. Rest of the algorithm logic building can be done over the period, right? So I'm going ahead. तो सर, ये अभी आपने जो लॉजिक कहा, तो इसको थोड़ा सा algorithm में कन्वर्ट करते हैं. मैंने कहा ना कि वी विल ऑलवेज गो इन सिमिलर फैशन. फर्स्ट थिंकिंग, देन अल्गोरिथम, देन इंप्लीमेंटेशन. ऑब्वियसली इंप्लीमेंटेशन होने के बाद में एनालिसिस. मेनी टाइम्स आई हैव सीन दैट लोगों को बहुत जल्दी होती है. सर इसका टाइम कॉम्प्लेक्सिटी क्या है? आई ऑलवेज कीप टेलिंग अ पीपल, टाइम कॉम्प्लेक्सिटी बाद में सोचना, पहले अल्गोरिथम लिख लेना. हेलो, टाइम कॉम्प्लेक्सिटी बाद में सोचना, पहले अल्गोरिथम लिखना. You always remember that, sir, is efficiency of algorithm is important. 100% the efficiency of algorithm is important, but trust me, the accuracy of algorithm is more important than the efficiency. I hope you got my point. Let's say that, sir, my algorithm is not accurate, but I'm worrying about efficiency. Does it make sense? से मेरा बाइनरी सर्च काम ठीक से कर नहीं रहा है, एंड देन आई एम जस्ट आस्किंग से इसकी लॉग एन आनी चाहिए, लॉग एन स्क्वायर आनी चाहिए, क्या आनी चाहिए? आई गेस दैट वुड बी स्टूपिड वन, इजंट इट? सो ऑलवेज वी विल फॉलो द सेम वे कि फर्स्ट थिंकिंग, then algorithm on paper, then implementation. If everything is okay, we understood algorithm is running, and then we talk about analysis of that algorithm, whether it is fast, whether it is slow, whether it is o of n, whether it is o of log n, वगैरह 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 वगैरह, ये उसके बाद में आएगा. So you keep this thing in mind and tune yourself accordingly, so that your life is also simple and my life is also simple. Anyway, I'll go ahead. So sir, how do you find out a midpoint? Like for example, right now I have got an array of 9 elements. इन 9 एलिमेंट का हम लोग मिड पॉइंट कैसे निकालते हैं? तो 9 एलिमेंट का मिड पॉइंट, तो सर यू वांट टू से लाइक 4.5 और समथिंग लाइक दैट, और नॉट रियली. यू प्लीज अंडरस्टैंड दैट, नॉट रियली. ऐसा कुछ करने की जरूरत नहीं है. यू फॉलो द वेरी सिंपल लॉजिक. यू ट्राई टू गेट द नियरली हाफ. यू ट्राई टू गेट द नियरली हाफ. आई रिपीट, यू ट्राई टू गेट द नियरली हाफ. एक पॉइंट कम हो गया या एक पॉइंट ज्यादा हो गया, उससे कोई फर्क नहीं पड़ता. correct? If you have 100 pages book, you can make it 50-50. If it is let's say 101 पेज, then एक में 50 और एक में 51 आने वाले हैं, तो सर उससे कुछ फर्क पड़ेगा क्या? To be frank, not at all. The algorithm remains same. So do not think a lot on like unnecessary stuff. पहले देख लो. Ultimately your algorithm is going to work, and then if at all questions are there, then your questions are also welcome. No problem. चलो हम लोग आगे बढ़ रहे हैं. And I'm saying that this is nothing but हाँ, एल्गोरिथम कहाँ से शुरू करना है? अभी हम लोग एल्गोरिथमिक थॉट प्रोसेस है. लॉजिक मैंने आपको क्या बताया? इसको एक-एक पार्टीशन को 50% डिवाइड करना है, की एलिमेंट चेक करना है, डिसाइड करना है, लेफ्ट में जाना है या राइट में जाना है, और वापस से उस पार्टीशन को वापस से 50% में डिवाइड करना है. दिस इज अ ओवरव्यू. Actual implementation wise, I said that let us consider that we will have two markers. One is like a left index. ये index है, ये number नहीं है. It is not 11. It is 0. I'm talking about. And this is like a right index. This is like a left index, and this index is right index. So first index I'm saying left. The next index I can say like a right. And then you want to find out the midpoint. The midpoint for the midpoint. So how do I calculate the midpoint? A midpoint is very simple. For me, the midpoint formula is as simple as what is that? Left plus right divided by 2. See, my formula is very simple. Left plus right divided by 2. Parenthesis to be noted. Don't say left plus right by 2. It's like a left plus right in parenthesis divided by 2. In this example, what is left? Oh, left is 0. What is right? Right is 8. 0 plus 8 is 8. Divided by 2 is 4. So I find like a middle. Oh, this is like a middle element. So sir, which element you are trying to find out? Oh, I'm trying to find out. वो तो मैं बताना ही भूल गया. The element under consideration, the element that I'm trying to search, the element that I'm trying to search is, let's say, 6, 77. This is the element that I want to search. Now in this particular case, how do I progress? और एक काम करते हैं, we'll try to search 88. हाँ, let us get started with. So what is the first thing? You find out a middle element. You first check, listen carefully. You first check the key that you want to search. Is it matching the element? Is it matching the element? Is it matching the middle element? There is some question someone is having. If left plus right is 4.5, then let it be. You should not forget that integer divided by integer gives you integer. I hope Utkarsh that is clear. हम लोग जावा में, हम लोग C++ में, so Java C++ rules are very simple that integer divided by integer gives you integer, and the result has to be like 4 only. So अगर left plus right by 2 अगर आपका 4.5 आता है, तो 4.5 आपके मिडल में नहीं आने वाला है, मिडल में 4 ही आने वाला है. And always understand that ये हमारे indexes है. Index cannot be 4.5. Not. अगर आप लोग कल किसी ऐसे लैंग्वेज में काम कर रहे हो, सो जिस लैंग्वेज में हम लोग जब डिवीजन लेते हैं तो हमें पॉइंट में आंसर आता है. लाइक पाइथन में जब हम लोग करते हैं, लेट्स से 0 + 9 डिवाइड बाय 2, 0 + 9 डिवाइड बाय 2, आंसर कम्स आउट टू बी 4.5. तो सर ऐसे केस में आप क्या करते हो? कुछ नहीं, ऐसे केस में हम लोग टाइपकास्ट करते हैं. सो वी टाइपकास्ट इट टू द इंटीजर एंड वी से दैट नहीं, आई डू नॉट वांट दैट 0.5 पार्ट, आई वांट ओनली द पार्शियल पार्ट ओनली. आई होप दैट इज क्लियर. Let's continue further. I'm saying that if key is equal to mid, I what is the meaning of this? अगर मैं 55 सर्च कर रहा होता, तो I'm saying that I found 55. I found for 55. You can simply return the middle index. Oh, that is very simple. But unfortunately, in our example, हमें वो नहीं करना है. ये तो हमें क्या करना है? अब हमें क्या करना है? आई गेस वी शुड. अब मुझको कहां पर सर्च करना चाहिए 88 को? इन्हें लेफ्ट पार्ट में सर्च करना चाहिए, राइट पार्ट में सर्च करना चाहिए? मुझको लेफ्ट पार्ट में सर्च करना चाहिए, राइट पार्ट में सर्च करना चाहिए? राइट पार्ट में. हाउ डू यू डिसाइडेड? हाउ डू यू डिसाइडेड? द की दैट यू आर सर्चिंग is greater than the middle element. Since key is a greater than the middle element, I said that I should focus onto the right partition. So agar if you say that key is less than the middle element, what do you want to do? I'm saying that focus on left partition, a focus on left partition, and else, else I can say that focus on right partition. A focus is not a English word or Java, or sorry, is not a Java word or data structure word. I'm just saying that in general English, I'm just saying that since it is greater, now I should only bother about right. What I'm trying to tell you, have a look at this. What I'm trying to tell you, in this particular case, ये जो array का जो part है, इसमें मेरे को कोई लेना देना नहीं है. प्लीज अंडरस्टैंड दैट. ये जो एरे का पार्ट है, इससे भी मेरे को कोई लेना देना नहीं है. आई नीड टू वरी अबाउट दिस मच ऑफ पार्ट. Please note, I'm not even worried about the middle element. Why I'm not worried about middle element? Middle element is already compared. A 55 मेरा already compare करके हो चुका है. So I do not even bother about that. What I'm bother about? Oh, I bother about the element after that. Oh, element after that, I'm going ahead. So how do I do that? I simply say that let us consider for the next iteration, for the next iteration, I want to consider only this much as my array. If for the next iteration, I want to consider only this much of my array where the left is equal to 5 and right is equal to 8. But sir, how do I consider this much as an array? Oh, that is pretty simple. All I need to do is that I need to say left is equal to mid plus 1. All I need to say is that left is equal to mid plus 1. I repeat, मैं mid को वापस से कंसिडर नहीं कर रहा हूं क्योंकि mid को ऑलरेडी कंपेयर किया जा चुका है. हम लोगों ने पहले mid की इक्वालिटी ही कंपेयर की थी. Since it is not equal, that is the reason we went ahead. And now since we went ahead, we are just comparing कि ये left partition में है या फिर right partition में है. अगर ये right partition में है, अगर right partition में है, then I want to repeat the same process for all elements after the mid. सो उसमें से राइट पार्ट तो अपनी जगह पे सही है, उसमें कोई चेंज नहीं होने वाला. द लेफ्ट पार्ट ऑफ द राइट पार्टीशन, द लेफ्ट ऑफ द राइट पार्टीशन should be mid plus 1. I hope people you are getting this. Then you continue further and again repeat the process. Oh, you repeat the process. I repeated the process. Bolo, what is to be done? Again find out the midpoint. Hey, what is the new midpoint? 5 plus 8 divided by 2. 5 plus 8 divided by 2, 13. 13 divided by 2 comes out to be 6.5. But 6.5 is not to be considered. 0.5 is to be discarded. So you can say only 6. Okay, I got this. I got this. And again, you continue further and again you compare. Is it matching? Oh, I see that. Sorry, it is still not matching. And if it is still not matching, what is to be done? Again, you check whether 88 is greater, whether 88 is smaller. Again, I found that 88 is greater. Again, if 88 is greater, I understand that I need to focus only onto the right partition. And if you want to focus only onto the right partition, again, I need to repeat it once again. Wait, left is equal to mid plus 1, and you repeat the story once again for this. You repeat the story once again for this. Chalo, go ahead. Repeat the story. Now tell me once again, mid is equal to left plus right by 2. 7 plus 8 divided by 2. 7 plus 8 divided by 2 comes out to be 7. 7.5, 0.5 is to be scrapped. And then I can say that, oh, middle is again pointing to this. Now again you compare. Oh, is this matching? Is keys matching? Yes, key is matching. And if it is matching, return that particular middle index. So your index 7 is to be written. So your logic becomes that simple. Obviously, हम लोगों ने जो एग्जांपल लिया था उसमें हर एक जगह पे हमें सिर्फ राइट पार्टीशन में जाना पड़ा था. लेकिन अगर हम लोग ऐसा कोई एग्जांपल लेते हैं जहां पर लेट्स से फॉर एग्जांपल वी विल डू इट वंस अगेन एंड दिस टाइम वी विल ट्राई टू सर्च लेट्स से एलिमेंट 22. You try to search the element 22, we will repeat the whole process once again and you see that what we need to do it over here. Again I suggest, एक बार तो ऑलरेडी मैंने करके दिखाया है, now it is a good time कि आप लोग उसको मेरे साथ कर सकते हो. Keep your paper, your pencil ready, do it with me, you will be more comfortable. At the end कोड लिखने का काम हो जाएगा, but पहले algorithm को digest करो कि what exactly it is. Do not by heart the code, by the probably the mechanism how this code came from, which diagrams that we have drawn and which process that we have followed is more important than the actual code. The code will keep changing from language to language. Actually, let us just go back. What we have got is like a left, this is right, and this is the middle on the first iteration. I'm trying to search 22 and I'm doing from scratch once again. Chalo, start. A left is equal to 0, the first index. Right is last index. A last index is typically n minus 1. You know that. If the n elements are there, then the last index would be n minus 1. Go ahead, find, what is that? Mid is equal to left plus right by 2. Yes, you found 4. That is not a problem. What is next? Is it matching 22? Sorry, it is not matching 22. Now, where do I focus? Where do I focus? 22 is smaller than 22 is smaller than the 55. Since 22 is smaller than 55, I should focus only on this much of array. Oh, I should focus only on this much of array. Why don't you go step ahead? And I said that I'll just take it over here. Okay, that is good. What is next? What is next? Repeat the process. Hey, how do you do that? You simply run right is equal to middle minus 1. Right is equal to middle minus 1, so that now you are focused on this. Continue further. Now left plus right by 2. So 0 plus 3 divided by 2 is 0 plus 3 divided by 2 comes out to be 1. Oh, you comes out to be 1, and since it comes out to be 1, you check, is the element, is it the same element that you're looking for? Is it the same element that you're looking for? Yes, absolutely. It is the same element that I'm looking for. If it is the same element that I'm looking for, I should be simply returning an index. Please note, I repeated this algorithm second time. So you find that I'm just continuing further. So in either case, so we have written a kind of a loop, and in either case, we found the element. Let me just go ahead and repeat this algorithm one more time. सर बस समझ में आ गया? हाँ, मुझको पता है आपको समझ में आ गया, आप इंटेलिजेंट हो, but still I have to repeat it one more time, considering one more case. Considering one more case, and the case that I want to consider is, let's say that I'm trying to find out element. I'm trying to find out element 40. A 40 is the element that I'm trying to search. Again, do the paperwork and let's see what happen. ये अभी तक आप लोगों ने नोट किया है कि आपको ये वाला पार्ट रिपीट करना है again and again, again and again, again and again. That is something that we understood. But let's see how much time that we need to repeat it. Let us get started. अरे मिडल वहां पर कैसे चला गया? मिडल नहीं वहां पर भेजना है. Right is at the end and middle is at the center. The element that I'm searching, please note, it is 40. Element that I'm searching is, let's say, 40. Let us begin. What is the first iteration? First iteration, middle is equal to left plus right by 2. So obviously the middle is going to be 55. Okay. The element that I'm searching is 40. A 40 matlab, it has to be, it is smaller. So you consider that it has to be into the left partition. It has to be in left partition. How do you consider left partition? I simply say that right is equal to middle minus 1. Right is equal to middle minus 1. You consider it over here. Okay, you continue further. You continue further, you find out the middle once again. A 0 plus 3 divided by 2, this comes out to be middle. Oh, this comes out to be middle. Now it is 22. And now, again you are comparing. Please note that this was the second iteration. ये जो था, it was the second iteration. You continue further. You continue further, you realize that it is 22. What is to be done? If it is 22, what is to be done? Now you see that 40 is matching, 40 is not matching. So again, 40 is greater than 22. Since 40 is greater than 22, I need to focus onto the right partition. I need to focus only onto the right partition, and to focus onto the right partition, I can simply say left is equal to mid plus 1. Go ahead, left is equal to mid plus 1. Again, I'm trying to compare. Again, I'm trying to find out the midpoint. You find the midpoint. Just a minute. I'm trying to find out the midpoint. So count midpoint. A 2 plus 3 divided by 2 comes out to be again 2. It comes out to be 2. It is there. Now again I'm comparing. This is my third iteration. Again I'm comparing and I still find that 33, the element that I'm searching, is still greater than that. If the element that you're searching is still greater than that, what is to be done? What is to be done? Again you continue further and you simply say that left is equal to mid plus 1. A left is equal to mid plus 1. So you are going on to the right partition once again. So let us continue once again. Abhi left or right, both are pointing. Please pay attention. Left and right, both are pointing to the same. So obviously, as you said, divide by 2 comes out to be 3 only. Okay, that is good. Now 44. Is it matching 40? Is this matching 40? Or not really? Even this is the last element, still it is not matching 40. And what is to be done? What is to be done? So you consider that the element should be into the lower half. You consider that element should be in the lower half. Because 40 is less than this. If the element is lower half, a lower half, so what do you say? I want to consider left partition. So right is equal to mid minus 1. A right is equal to mid minus 1. Have a look at this. Have a look at this. Have a look at this. And what do you see over there? Now this is something absurd that you see. What is absurd over here? लेफ्ट क्या था? आपका लेफ्ट वाला इंडेक्स था. राइट क्या था? आपका राइट वाला इंडेक्स था. लेफ्ट क्या था? लेफ्ट वाला इंडेक्स था. राइट क्या था? राइट वाला इंडेक्स था. But in this case, you find that the right is smaller than the left. I'm talking about right is smaller than the left, and this is something abnormal. This is something abnormal which indicate that the element is not available. Which indicate that ये condition सिर्फ तभी होता है कि when element is not available, and this is what tells me. See, पेपर वर्क करने से मुझको पता चला कि मेरा कंडीशन यहाँ पर क्या होना चाहिए. मेरा कंडीशन यहाँ पर ये होना चाहिए, where I can say that the right is less than left. When the right is less than left, at that time I can say that there are likely chances nahi. It means that the element is not available. Element is not available. That's it. In such case, I should always say return minus 1. Return minus 1. This is how you write algorithm. Okay, let us just quickly go ahead. Why don't you type the algorithm quickly and run it? Don't forget, this algorithm works only in a sorted array. So you first ensure that your array is sorted before you actually do the further operations. लेकिन फिलहाल तो मैं बाइनरी सर्च को लिखने वाला हूँ. Public static int, and I'm saying that it is binary search. सर एक नया प्रोजेक्ट नहीं बनाओगे? एक एक फंक्शन के लिए एक एक नया नया प्रोजेक्ट बनाना चाहिए. इतने आपके बुरे हल नहीं होंगे. And I have given proper naming conventions, so I'm very sure you will be able to find it out. So I'm saying somewhere it's like a binary search. Oh, it is there. Now it is binary search. I'm just continuing further. What is next? Let us follow the algorithm. What is the algorithm? You need left index, you need right index, and you also need kind of a mid index. You continue further. What is left? Your algorithm begin with left is equal to 0. Array ka left. Array ka right, which is the last index. Oh, last index, I can simply say that it is length minus 1. A length minus 1, that is the last index. Now you continue further. You are looking for, what is that? Middle element. Continue and count the middle element. How do you count the middle element? Middle element is equal to left plus right divided by 2. All right, left plus right divided by 2. You want to check, is it matching? Is key is equal to error of mid? If it is matching, just go ahead and return the index. It's very easy. However, if key is less than error of mid, it is less than error of mid, I need to focus onto the left partition. And to focus onto the left partition, I should simply say that right is equal to mid minus 1. Else, I want to focus onto the right partition. To focus on right partition, I can simply say mid plus 1, and I want to repeat the process. While left is less than right. While left is less than right, जब तक left right से कम है, तब तक everything is going well. You just repeat the process. However, जब ये condition false हो जाएगा, ये condition कब false? Sorry, not left. Left is less than or equal to. That is correct, Jaideep. It is less than or equal to. When Shubham, when right becomes greater, then you want to come out. Sorry, when right become less than left, then you want to come out. It is a condition to come out. It is a condition to come out. So मुझको repeat कब तक करना है? मुझको repeat तब तक करना है जब left index is less than right index. When the left index is less than right index, तब तक आपको repeat करना है. तब तक आपको repeat करना है. Moment right becomes less, moment right become less, that is somewhere you want to come out. Okay, understood? In that particular case, I can say return -1. I can say return -1. So that's it. That's it. That is the only thing that I need to do in algorithm. Nothing more than that. Oh, why don't you run it? Why don't you run it? But what is the problem to run this? What is the problem to run this? I want the array to be in a sorted order. So I suggest two things, two ways. या तो ये array लेते वक्त ही sorted order में ले लो, option number 1, or option number 2, since we are Java experts, we already know that array.sort method will ensure that your array is sorted. So I'm just simply finding, oh, this is like array sorted, and then after this, I will be repeating this once again. All right. Is this clear? Whatever is done in front of you. ये मैंने एरे जो भी है, अगर आप लोग यूजर से ले रहे हो तो यू नेवर नो दैट यूजर हमेशा सॉर्टेड ऑर्डर में देगा. तो यहाँ पर मैंने पहले एरे सॉर्ट किया. लीनियर सर्च कैन वर्क, एक मिनट, दिस कैन वर्क ऑन सॉर्टेड और नॉन सॉर्टेड एरे. हाउएवर, तो इसमें को तो कोई प्रॉब्लम नहीं है, बट दिस कैन वर्क ओनली ऑन, कैन वर्क only on sorted array, and that is the reason I just ensure that I've done a sorting over here. And if it is clear, why don't you go ahead, you and run this. You try to search element. Let's say I am trying to search 33. A 33 has to be at index 2. Okay, that I see. Let's say 99, which is probably at the last index. Yes, I see that as well. You say 11. Oh, it is at the index 0. That is also good. A पहला middle element हम लोगों ने कौन सा search किया था? 55. Within first iteration. Yes, this is also working. Lastly, let me try to find out something which is not available and it is saying not found. So ये दो बार क्यों प्रिंट कर रहा है? एक बार लीनियर सर्च से कर रहा है और दूसरी बार ये बाइनरी सर्च से कर रहा है. I hope that is going well. Why don't you people try it? Correct? So algorithm is pretty simple, pretty straightforward. Obviously, we want to discuss something more about the algorithm as well. As far as even time complexity is concerned, we want to talk about that as well. But I guess now it is almost 11 o'clock. I'm leaving you with the algorithm. You spend a little time on algorithm, or you have your tea, whatever, get fresh. And once you're fresh, we will continue once again and we will talk about the time complexity and then we'll move on to the recursion kind of topic, right? Where is that? If you have any questions, please keep them ready. I hope you are there. Okay, so I'm sure that you have done this, and algorithm that we are talking about, like I said, binary search. As the earlier, actually I was writing there the condition, I was writing a condition where it should be false, where it should be false. So earlier when I was explaining, I was writing right is when the right becomes less than left. So that is a condition where it become false. So you want to write a condition, आपको पता है यहाँ पर जो लूप होता है while loop, जब तक condition true होती है तब तक के लिए आपको repeat करना है. So obviously I have just done the modification accordingly. Yeah, no problem. I repeat once again. Earlier I was talking about at which condition I should stop. So I was talking about when what the block condition is. So when the condition become false, actually I should come out. So I was talking about that condition. Now I have written a corrected condition over there.
So कोई बात नहीं है. Now this is done. Binary search, it is working. So I guess we should also talk about what about time complexity, how it is going to execute, and you will find that this time complexity goes much parallel to what converting a number into binary. So it will be on a similar fashion. So what exactly it means? I'm saying that, see, let's say that you take an array of 16. You take an array of 16. I'm just purposefully taking a halfway proper number so that we can compare it. So I'm saying that you take an array of 16. In a first pass or in a first iteration, you realize either you want to go to the left part or you want to go to the right part. So ultimately, on a next, you will be focusing only on an array of 8, and then again you continued further. Again you continued further. On a next pass, again you are doing two parts, either left part or right part, not both. Either left part or right part, either one. So again you are going to like a 4, and then again you continued further. Again you say that, again you divide further like a part of two, either left or right, whichever it is, but it is only the two elements. And finally you reach to the single element in a partition, where you realize that either the element is present or element is not present. Either element is present or element is not present. So how many iterations actually it takes? So you can simply say that like a first iteration, second iteration, third iteration, and fourth iteration. So over here, the number of iterations or number of times the loop will be repeating is actually dependent on कि आपका division कैसे हो रहा है. Divide by 2, divide by 2, divide by 2, divide by 2. Worst case, a worst case, I'm saying that you are reaching to the last element. This is the worst case. There can be even a best case. What is the best case? Let's say the element that you are searching is a 55 itself. If the element that you are searching is a 55 itself, in a first go itself, you find out a mid, and then you continue with this. I hope you got the point. In that particular case, so it could be within a single iteration, you are finding an element. That is absolutely possible. But I'm saying that even worst case, let it be to the left, let it be to the right, or whatever, the number of iterations that you will take is actually depends on a division, depend on a partitioning logic. Roughly अगर कहना है, roughly अगर हमें कहना है, so you have a look at this. The number of iterations, I'm saying that, let's say for example, t is proportional to the number of iterations, where I is the number of iterations. I is the number of iterations. But do you know that how many iterations that we take in general? The number of iterations that you see in general, have a look at this. 2 raised to I is n. टेक अ लुक एट दिस. 2 raised to I in n. मैंने जानबूझ के अप्रोक्सीमेटली इक्वल टू लिखा है, क्योंकि ऐसा कोई जरूरी नहीं है कि आपके पास हमेशा एरे 16 का या 32 का या 64 का एरे हो. दैट इज नॉट नेसेसरी. सो समटाइम यू मे हैव which is not power of 2. That is the reason I use kind of approximate sign. So 2 raised to I is almost equal to n. What you are saying over there? यहाँ पर मैं आपको बताने की कोशिश कर रहा हूँ. If n is 16, example you see there, if n is 16, if n is 16, then 2 raised to 4, I'm taking nearby 4 iterations to reach or to search between 16 elements. Okay, that is good. So I understand the number of iterations over here. So problem is that I understand the formula. What about actual iterations? The actual iterations, अगर आपको actual iterations count करने हैं, let us take a log on both the sides. Let us take a log on both the sides. So how you can take that? So log of 2 raised to I is equal to log of n. I'm very sure आपने कभी 9th 10th स्टैंडर्ड में लॉगरिथम जरूर पढ़ा होगा, और अगर आपने पढ़ा होगा तो आपको पता होगा whenever it is a power, then it comes in a multiplication. So I into log n, and I into log n, you continue further. So I is equal to log of n divided by log of 2. A log of n divided by log of 2. That is good. But the time required is proportional to number of iterations. So time required in this case is proportional to log of n divided by log of 2. Oh, is it so? Yes, absolutely. You understand that 1 by log 2 is constant.
If 1 by log 2 is constant, you just take it out, and I can simply say that the time required is proportional to log n. And when time required is proportional to log n, you also understand that the time complexity is O of log n. And this is something that I was explaining कि जहां जहां पर partitioning का logic involved होता है, you see the logarithm factor picking in. जहां जहां पर पार्टीशनिंग इन्वॉल्व होता है, वहां वहां पर लॉगरिथम फैक्टर इज पिकिंग इन, जो आपको यहां पर दिख रहा है. आई बिलीव दैट इज ऑल राइट. दिस वॉट ऑल अबाउट टाइम कॉम्प्लेक्सिटी. तो सर हमें सारे मैथमेटिकल एक्सप्रेशंस वगैरह कहीं पर लिखने पड़ते हैं, या समवन इज आस्किंग इन इंटरव्यू? टू बी फ्रैंक, नॉट एट ऑल. नॉट एट ऑल. Again, as the like around, as I said, nearby 16 years I'm into the CDAC campus. So CDAC campus, what we see is that maximum time companies first ask you to write a code first. Write a code first, explain the paperwork, explain the algorithm very well. So as long as you are a good coder, so there are likely chances that you are placed. And then these time complexities, you should be definitely knowing the end results for solving some sort of a MCQ questions. So which can be the CDAC exam. Many of the companies, they took the technical exam. So technical exam में जो questions आते हैं, बहुत बार time complexity oriented questions आते हैं. और कभी कभी ऐसे भी आते हैं कुछ कुछ स्टैंडर्ड क्वेश्चन, लाइक फॉर एग्जांपल बाइनरी सर्च टाइम कॉम्प्लेक्सिटी इज ओ ऑफ लॉग एन. ये सारी दुनिया को पता है. सो देयर इज नथिंग ग्रेट इनटू दैट. सो दोस कुड बी द क्वेश्चन. Sometimes the question is they give some sort of algorithm, and for this algorithm what will be the time complexity? They just give some algorithm कि ये ऐसे ऐसे algorithm है या ऐसे ऐसे code लिखना है. So you write a code, and after that probably you are discussing, okay, what is the time complexity of this? Now when these kind of questions are there, as I said that in MCQ exams, at that time you should be in a position to understand it. You should be in a position to at least get an idea where out of 4 options that you can mark, and that is the reason I'm showing you the derivations. Otherwise these derivations are not directly important to you. जितने standards हैं, I would always recommend that वो by heart कर लो कि इसका time complexity O of log n है, linear search का time complexity O of n है. That is something that you need to by heart. But you always go through the mechanism once कि how you come from a derivation, so that अगर इसके सिमिलर कोई नॉन स्टैंडर्ड एल्गोरिदम होगा जिसके लिए अगर आपको सोचना पड़ा, तो आपको थोड़ा बहुत कैलकुलेशन पता होना चाहिए. दैट इज द रीजन आई वाज शेयरिंग विद यू कि व्हाट इज द टाइम कॉम्प्लेक्सिटी, व्हाट इज द एनालिसिस, और ये डेरिवेशन करके दिखाने का रीजन ही है, राइट? सो दिस इज ऑल अबाउट बाइनरी सर्च. इज द बाइनरी सर्च एल्गोरिदम इज क्लियर? अंडरस्टूड? इज गुड. And if again this algorithm is clear, we should go one more step ahead. And I want to see that there are certain algorithms which can be developed, not necessarily always using loops. There are alternative certain algorithms. So what kind of algorithms? If you take a look at this algorithm itself, take a look at this algorithm. What you are doing? You are starting with the array of, let's say, 8 elements or 16 elements. You starting an array of 16 elements, you find out the midpoint, and after you finding a midpoint, then you realize either you want to go to the right partition or you want to go to the left partition. Earlier you started with the array of 16, but then you say that if the element is greater, so you need to focus only onto the right partition. You need not to focus on left partition. So earlier you will started with the array of 16, now you are focusing only on an array of 8. Okay, that is good. And then again you can continue further. Again for that 8, you are not searching one by one. What you are again doing? Again you are saying that let us find out a midpoint, and let us decide whether should I go to the left partition, whether I should go to the right partition. Again you are doing the something similar. Again you continued. What do you want to do? Oh, I want to find out the midpoint once again. And after you find a midpoint, again you decide whether I should focus on an area of first 4 or I should focus on an area of next 4. What we are doing? We started with the area of 16, then we make it half, area of 8. Again we are making half, area of 4. Again we are making half, area of 2. Again we are making half, area of 1. This technique, where you are not trying to solve the whole problem at once, but rather you are dividing your problem into the multiple ones, the smaller problems, and then you try to solve that. And again, to solve that small part, again you divide it further, and again you try to solve that. This technique we refer it as divide and conquer technique. I'm very sure, being an Indian, we are well aware of the technique. Divide and conquer technique is the same technique that British followed for us, and Indians are really good at that. So divide and conquer. What all we are doing is that, what all we are doing is that we are not trying to solve the whole big problem. We are trying to divide the problem into the smaller problem and trying to solve that. Again, divide it into the further smaller problem and trying to solve that, and so on and so forth. So the typical, I'm saying that this binary search algorithm is typically, you say that it's a divide and conquer kind of problem. But most of the time, again, I'm not saying always, but then yes, almost all the time, जहां जहां पर divide and conquer type of problems होते हैं, जहां जहां पर divide and conquer type of problem होते हैं, वहां पर recursion makes it rule. So most of the divide and conquer problems we try to solve using recursion. तो दैट इज द रीजन आई टोल्ड यू दैट, मैं पहले आपको linear सर्च बताता हूँ, आपको बाइनरी सर्च बताता हूँ, देन विल गो ऑन रिकर्शन. वी विल टेक अ ब्रीफ लुक एट द रिकर्शन concepts. आई एम वेरी श्योर आप लोगों ने इससे पहले पढ़े होंगे बिफोर यू कम डाउन टू द CDAC course, so you must be knowing that. I will revise it. If you have any questions, this is like an ideal time that where you should be asking that. We will sort out the issues of recursion, understand recursion, and once recursion is clear, then we will try to rewrite this algorithm once again. We will try to write the binary search algorithm once again, but now in a recursive manner. So is it what we are going to do? Yes, absolutely, and that is the reason recursion is there. Let's move on. So what is some very basic stuff of recursion? Or recursion simply means that a function calling itself is called as a recursive function. Absolutely. जब कभी किसी फंक्शन के अंदर खुद को ही कॉल दिया गया है, इट इज रिकर्सिव फंक्शन. प्लीज नोट, राइटिंग रिकर्सिव फंक्शन इज वेरी इंपॉर्टेंट स्किल. अगर आप लोग डेटा स्ट्रक्चर में कुछ आगे जाके करना चाहते हो, अगर डेटा स्ट्रक्चर में आप लोग आगे जाके कुछ करना चाहते हो, please understand that writing recursive functions is very much required. There are many problems which can be solved using recursion. Just now I told you the technique name. The technique that we see is a divide and conquer technique. So the divide and conquer technique, as I said that all the problems we try to solve it using recursion. तो binary search is not the only algorithm. आगे जाके quick sort आएगा, आगे जाके merge sort आएगा. ट्री के almost सारे algorithms they are recursive algorithm. So at that time, every time we may not go and invest our time to understand what is recursion and etc etc. So right now I'll just focus on what is recursion once, और वहां से आगे we will continue. So अगर आपको recursion relevant जो भी questions होंगे, first of all let me teach recursion. उसमें आपके सारे problem solve होने चाहिए. अगर कुछ problem रह जाते हैं तो let me know. We will take up them now, not probably every now and then, right? So how do we write a recursive function? To write recursive function, there are two things very important. Which two things very important? One, explain the process or a formula in terms of itself. So whatever problem statement is given, you please try to analyze the problem statement and you see that क्या इस problem statement को हम लोग उसी के terms में explain कर पाते हैं, is one. And then you need to find out the terminating condition. A terminating condition many time also referred as a base condition. Base condition. Please note, let me focus on to the two halves. The first half, the first half where I want to focus on how to write recursive functions, and the second half how recursive function get executed. Please do not mix up. I'll cover both. I will cover both. लेकिन अभी जो मैं आपको बात कर रहा हूं, यूजुअली ऐसे होता है कि जब कभी रिकर्शन चलता है, जब कभी रिकर्शन चलता है, तो व्हेन यू आर टीचिंग स्टूडेंट्स हाउ टू राइट, so they are thinking how this is executing, and when you start explaining them how this is executing, then you say that लेकिन सर लिखना कैसे है? These are two different things. Do not mix up. अभी के लिए the first focus is that how to write recursive functions, and then the second focus is that how how the recursion is called. That is the second step that we will see it separately. So right now just focus on one part. What is that? How to write the recursive functions. So how to write recursive function? Whatever problem statement in your hand, divide, look at the problem statement, look at the problem statement and try to explain it in terms of itself. Try to explain it in terms of itself. Sir, example, the most common example I'll take it first. You say factorial. So you always say that n factorial is equal to n into n minus 1 factorial. Is it? Yes, absolutely. N factorial is equal to n into n minus 1 factorial. And if this is a problem statement, so you say that 4 factorial, if you just count it, I'll just go ahead. You look like a 4 factorial. 4 factorial is nothing but 4 into 3 factorial. Okay, that is good. And then 3 factorial is equal to 3 into somewhere, let's say 2 factorial. Or you continue further, 2 factorial is equal to 2 into 1 factorial. Oh wait, or for that sake, 1 factorial is equal to 1 into 0 factorial. Or you continue further, 0 factorial is equal to 0 into minus 1 factorial. Is it so? Is it so? Oh, not at all. So 0 factorial is not 0 into minus 1 factorial. I said that 0 factorial is always 1. Now please don't ask me who told you. This is what a basic mathematics. So the mathematical rule says that this value is constant and you cannot have a factorial of a negative one. So I'm saying that this one is nothing but the base condition. So you find that explain the process in terms of itself. When you're talking, I'm talking about this. And the second thing, when you say base condition or terminating condition, I'm talking about this. At the beginner level, listen, at the beginner level, we always say that, so how to find out terminating condition? The beginner level, you find a terminating condition by doing some paperwork. By doing some paperwork and understanding, okay, 4 factorial is equal to 4 into 3, 3 factorial is 3 into 2, 2 factorial is 2 into 1 factorial is 1 into 0 factorial, and 0 factorial is equal to 1, where after doing paperwork you realize that, oh, that is the end, that is the end. So यहाँ पर जो बेस कंडीशन या टर्मिनेटिंग कंडीशन हम लोग ढूंढा था, वो हम लोगों ने स्टेप बाय स्टेप हम लोगों ने अंदर तक जाके ढूंढा था. तो सर इन रियल वर्ल्ड प्रैक्टिकली हम लोग ऐसे करते हैं. सी जिन अल्गोरिदम्स के लिए पॉसिबल है, जहां पर ऑन पेपर पॉसिबल है, आप लोग उसको ऐसे कर सकते हो. बट बट जब आप लोग कॉम्प्लेक्स एल्गोरिदम्स में जाओगे, इन कॉम्प्लेक्स एल्गोरिदम्स, दिस इज कंसिडर्ड एज क्वाइट स्टूपिड प्रैक्टिस. अगेन मैं कह रहा हूँ बिगिनर लेवल पे दिस इज गुड. सो अभी अभी आप लोग शुरुआत कर रहे हो, सो इट इज वर्थ, यू गो बैक, यू डू द पेपर वर्क, यू कम डाउन टू द लास्ट लेवल कि जहां पर हम लोग कुछ नहीं कर सकते. सो दैट इज ओके, दैट इज एक्सेप्टेबल. हाउएवर, जब आप लोग एक्चुअल डेटा स्ट्रक्चर में आगे जाके एल्गोरिथम्स लिखना चाहते हो, बड़े बड़े एल्गोरिथम लिखना चाहते हो, देन दिस इज नॉट द वे दैट यू शुड फाइंड द बेस्ट कंडीशन. अभी जो मैं बता रहा हूँ उसको ठीक से सुनना. देन सर व्हाट इज द वे टू फाइंड आउट व्हाट इज बेस्ट कंडीशन? In that, you consider the problem statement, you consider the recursive formula, and on that recursive formula you think of the smallest input that you can give, where where the formula doesn't hold true. What I say that recursive formula, ये तो recursive formula आपको दिख रहा है. मैं क्या कह रहा हूँ कि don't do the paperwork and then come down to that. Look at the recursive formula and start thinking. You need to use your intuition कि what could be the smallest input for which this particular formula doesn't hold true. And then you realize that, oh, 0 factorial has to be 1. A 0 factorial is equal to 1 because 0 is the smallest value whose factorial can be calculated. I hope you got the point. If you're not got the point, I have another example. Another example, you said x raised to y is nothing but x into x raised to y minus 1. So what again it is? Again what it is? I'll just repeat it. Let's say you are trying to calculate 2 raised to 3. You are trying to calculate 2 raised to 3. So 2 raised to 3 is 2 into 2 raised to 2. I hope you understand. 2 raised to 2 is equal to 2 into 2 raised to 1. Yes. 2 raised to 1 is equal to 2 into 2 raised to 0. Okay, that's good. And 2 raised to 0, I guess यहाँ से आपको आगे जाने की जरूरत नहीं है. इसको आपको 2 raised to minus 1 करने की जरूरत नहीं है. This is something I see the base condition. So again, by doing the paperwork, I can come to that. However, I'm saying that why don't you think bit rationally and understand that x raised to anything. So x raised to कौन सा minimum number होगा कौन सा मिनिमम नंबर होगा जहां पर आपको ये रोकना पड़ेगा? यू ऑटोमेटिकली अंडरस्टैंड दैट ओ x रेज़ टू 0 इज गोइंग टू बी 1, x raised to 0 is going to be 1. That is pretty simple for you. And then again you continue further. For that sake, bit complicated example. Bit complicated example. कोई मुझे बताएगा ये example किस बात का है? By looking at this, t raised to n is equal to n minus 1 plus n minus 2. Yes, it is an example of a Fibonacci series. It is an example of a Fibonacci series where any term is addition of two previous terms. Any term is the addition of two previous term. बट फॉर एनी टर्म 10th टर्म निकालना है तो पिछले दो टर्म्स का एडिशन निकालो, उसमें से 9th टर्म निकालना है तो पिछले दो का एडिशन करो, 8th टर्म निकालना है तो उसके पिछले दो का एडिशन करो। एक कहीं ना कहीं पर तो उसको आपका फिबोनाची सीरीज का कोई तो स्टार्टिंग पॉइंट होना चाहिए, कहीं ना कहीं पर तो आपने जाके रुकना चाहिए, यस एब्सोल्युटली रुकना चाहिए। एंड दैट इज समथिंग आई एम टॉकिंग अबाउट, इट इज लाइक अ फर्स्ट एंड सेकंड टर्म यू कैन से वन। तो सर ऐसा कोई जरूरी है कि वन से चालू होता है? नहीं, इन फ्यू बुक्स यू फाइंड दैट फिबोनाची सीरीज इज स्टार्टिंग फ्रॉम जीरो। सो टी रेज टू जीरो, सॉरी टी रेज टू वन इज जीरो एंड टी रेज टू वन इज अ वन। सो कुछ बुक्स में जीरो और वन लिखा है, इन फ्यू बुक्स प्रोबेबली इट इज वन वन लिखा है, कोई फर्क नहीं पड़ता। यू डिसाइड डिपेंडिंग ऑन योर रिक्वायरमेंट। सो अल्टीमेटली यू अंडरस्टैंड। तो सर एग्जाम्पल क्या है? अगेन यू डू नॉट स्टार्ट डूइंग अ पेपर वर्क कि चौथा टर्म मतलब पिछले दो का एडिशन, तीसरा टर्म मतलब पिछले दो का एडिशन, ऐसे मत करो। कीप इट सिंपल। व्हाट इज लाइक लोएस्ट एन वैल्यू that can be considered? So you said first and second term is something that you worry about. If the first and second term that you worry about, you just make this as your base condition. I hope this is making picture clear. If it is not, still there is one more example. और हर बार आपके पास ऐसे रेडीमेड फॉर्मूलाज होंगे, इसी कोई गारंटी नहीं है। दैट इज द रीजन आई एम सेइंग दैट एक्सप्लेन द प्रोसेस और फॉर्मूला इन टर्म्स ऑफ, जहां पर फॉर्मूला होगा ठीक है, लेकिन अगर फॉर्मूला नहीं होगा तो कहीं ना कहीं तो कुछ तो प्रोसेस होगी। आई एम टॉकिंग अबाउट दैट। लेट्स से यू वांट टू फाइंड आउट प्राइम फैक्टर्स ऑफ एन। या हाउ डू यू फाइंड आउट प्राइम फैक्टर्स ऑफ एन? किसी भी नंबर का प्राइम फैक्टर निकालना है, व्हाट डू यू डू? किसी भी नंबर के प्राइम फैक्टर्स निकालना है। लेट्स से 24, 24 के प्राइम फैक्टर्स आपको निकालना है। हाउ डू यू फाइंड द 21st प्राइम फैक्टर? सो यू फर्स्ट फाइंड द फर्स्ट प्राइम फैक्टर, लेट्स से इट इज 2। सो आई फाइंड द फर्स्ट प्राइम फैक्टर एंड आफ्टर दैट व्हाट यू डू? 24 का पहला प्राइम फैक्टर है 2। अब उसके बाद में आप लोग क्या करते हो? उसके बाद में बचा क्या? उसके बाद में बचा क्या? उसके बाद में बचा 24 डिवाइडेड बाय 2, लेफ्ट 12। अब आप लोग 12 के प्राइम फैक्टर्स निकालते हो। एम आई करेक्ट? हेलो? हाँ, देन यू फाइंड आउट द प्राइम फैक्टर्स ऑफ 12। फिर 12 का पहला प्राइम फैक्टर है अगेन 2, पहला प्राइम फैक्टर है 2, देन अगेन 12 डिवाइडेड बाय 2 इज 6। सो अगेन अभी आप लोग 6 का प्राइम फैक्टर निकालते हो, and this way you continue with the story. So what you are doing is that you get the first prime factor of n, you get the first prime factor of n, and then you repeat the process for the factors of n divided by the prime factor, n divided by that prime factor, and you again the repeat the process. I'm just trying to tell you the formula कि this way you can continue. जानबूझ के मैंने इसका terminating condition नहीं लिखा है। Can you please tell me what should be the terminating condition for this? इसका base condition क्या होना चाहिए? इस recursion का base condition क्या होना चाहिए? What should be the base condition of a recursion कि कहां पर जाके आपको रुकना है? At what point? Is it 2? I would simply say that अब वैसे आप लोग 2 कर सकते हो। 2 is bit dangerous because let's say for example you started with the number 7. You started with the number 7, you are never going to reach to 2. So I can simply say that either you say factors of 1 is going to be 1, a factors of 1 is going to be 1, and you can skip that 1 because 1 वैसे हम लोग प्राइम फैक्टर में काउंट नहीं करते। बट अल्टीमेटली व्हेन अ नंबर इज डिवाइडेड बाय इटसेल्फ इट रीच टू 1, दैट्स इट। सो दिस शुड बी काइंड ऑफ योर बेस कंडीशन। तो हम लोग हमेशा सोचते हैं कि इसका स्मॉलेस्ट पॉसिबल इनपुट क्या होगा? वो स्मॉलेस्ट पॉसिबल इनपुट 1 है। अब 1 के फैक्टर्स एक ही रहेगा, इसके अलावा और कुछ नहीं हो सकता। दीज आर द एग्जांपल्स, few examples that I'm telling you. Again, you can take a story one more step ahead. You talk about like a binary search for the moment. अभी हम लोग बाइनरी सर्च के बारे में बात कर रहे थे। तो सर बाइनरी सर्च हम लोग रिकर्सिव मैनर में कैसे सोच सकते हैं? हाउ वी कैन थिंक ऑफ बाइनरी सर्च इन अ रिकर्सिव मैनर? Again, I'm just focusing on how to write the algorithm. How algorithm execute, I will come back to that. How do you repeat the binary search in a recursive manner? So binary search in recursive manner, I said that you start with the array. See that you start with the array, that is good. Once you start with the array, what is your first step? Yes, first step still remains same. You find the middle and check if it is matching. If it is matching, you return. But if it is not matching, if it is not matching, if the element is smaller, if the element is smaller, search in a left subtree. Search in a left subtree. Otherwise, search in a right subtree. So again, you are explaining binary search in terms of binary search. You are explaining binary search in terms of a binary search. What you are saying? You are simply saying that find the middle, compare the middle. If the middle is matching, that is good. But if the middle is not matching, then either search in a left partition or search in a right partition. By the way, what is your left partition? Your left partition is left to mid minus 1. But what is your right partition? My right partition was probably mid plus 1 to right. I hope you agree. So I'm saying you first find out a midpoint. If this is matching, nothing much to be done. Return from there. Return from there. But if it is not matching, search in a, let's say, left to mid minus 1. Search in this part. Otherwise, search from mid plus 1 to right. Search in a right part. Array, whatever I'm saying, is it logically correct? Is it what you think in a recursive manner? So please understand that recursion, अगर ठीक से देखा जाए, it is one of the easiest way to write a code. Recursion अगर ठीक से देखा जाए, it is one of the easiest way to write the code. We will also discuss what are the pros and cons of recursion. So तब मैं आपको बताऊंगा ही कि क्या हो सकता है, क्या नहीं हो सकता है. But still, अभी आप लोग जो logic लगा रहे थे, what was your logic? Your logic was very simple. Your logic was as simple as you are simply saying that mid is equal to left plus right by 2 if key is matching a of m. You already said that return key. But otherwise what you are saying, if key is less than the middle element, if key is less than the middle element, I want to do the binary search once again. I want to binary search once again, but now I want to search that key. I want to search a key into the left partition. And what is my left partition? My left partition is left to mid minus 1. A left partition is left to mid minus 1. Otherwise, I want to search it into the right partition. And what right partition is saying? Right partition, a searching in a right partition is again as simple as what I can say. A right partition कहाँ से कहाँ तक? Mid plus 1 to right. Please note how easy it is. Something that you are doing on a paper, something that you are doing on a paper, something that you are thinking logically, you can try to put it into the code. You can try to put it into the code. And this is something, I always say that this is the biggest advantage of recursion. Recursion क्यों करना है? Recursion जैसे आप लोग सोचते हो, जैसे आप लोग what is that? This is like a human thought process. ये सिर्फ ब्रिटिशों की नहीं है. It's like in general, it is a human thought process, divide and conquer thought process. So as whatever that you thought of, you try to write the code which is parallel to that. People, मैं नहीं कह रहा हूँ ये स्टूडेंट्स का प्रॉब्लम है, उनको मुश्किल लगता है, बट जो लोग एक्चुअल काम करते हैं, they always say that recursive codes are more easy to read and easy to understand. Easy to read and easy to understand because you are very clear कि आपको exactly करना क्या है, right? Don't worry, हम लोग actual binary search के ऊपर बाद में आएंगे. मैं सिर्फ आपको बता रहा था how to write the recursive function. How to write the recursive function. The typical way that you write the recursive function. Take a look at this. Typical way you write the recursive function. अब जो आप लोगों ने factorial का function लिखा था, what is the factorial logic? You simply say that logic आप लोगों ने क्या लिखा है? Oh, mathematically you are written n factorial is equal to n into n minus 1 factorial. As you said so, go ahead and simply say that n into factorial of n minus 1, that is nothing but my result, and I want to return that result. तो जो आप लोगों ने मैथमेटिकली लिखा है वही चीज आप लोग कोड में भी लिख रहे हो, नथिंग ग्रेट. But at the same time, wait, you want to also check for the what is that base condition. Yeah, what is the base condition? Oh, 0 factorial is equal to 1. क्योंकि यहाँ पर आप लोग रिकर्सिव कॉल दे रहे हो. The function is going to be called again and again. A function is going to be called again and again, again and again, again and again. तो कहीं ना कहीं पर तो आपको रुकना पड़ेगा. सर कहाँ पर रुकना पड़ेगा? So you say that is the base condition. If n is equal to 0, 0's factorial is equal to 1. So you see the paperwork that you have done and the code that you have written goes quite hand in hand. Paperwork that you have done and the code that you have written goes quite hand in hand. I hope this is clear. So writing code becomes very easy with the recursion. ये मैं बताने की कोशिश कर रहा हूँ. मैंने कहा ना सिर्फ लोगों का प्रॉब्लम क्या होता है वो भी मैं बता रहा हूँ. अभी इतने सालों से मैं रिकर्शन पढ़ा रहा हूँ. सो आई ऑलवेज फाइंड दैट कि आप लोग बच्चों को ये पढ़ाओ हाउ टू राइट रिकर्सिव कोड. सो दे हैव गॉट अ क्वेश्चन, सर लेकिन ये रन कैसे होगा? हाँ वेट, दैट इज टू बी डिस्कस सेपरेटली. सो यू लर्न वन स्किल एट ए टाइम. सो यू नो रिकर्शन पढ़ने का भी टेक्निक वही है, डिवाइड एंड कॉन्कर. So you divide into the two parts. One part, the programming skills. Second part, understanding internals. Correct? If you divide these two things, your life become very easy. The another common problem why people find recursion difficult. Let me tell you that as well. The most common problem that I have seen, people find recursion is tough because they start learning recursion in a very wrong way or for a very wrong problem. Where recursion is most useful, the recursion is most useful in a technique like divide and conquer. In the recursion is most useful in technique like divide and conquer. You start learning recursion on a stupid examples. There are, you know, the ये psychological problem है that you always keep comparing with the alternative way of doing it. So you know, अब जिस किसी को भी ये recursion समझ में नहीं आता, he will always, you know, write the code everything. उसके दिमाग में एक क्वेश्चन हमेशा बना रहता है, सर इसको सीधे साधे लूप से लिख सकते हैं, why we are making it that complicated? हाँ डेफिनेटली ये आपके दिमाग में, और जब तक आपके दिमाग में ये रहेगा, यू आर नेवर एबल टू कॉन्सेंट्रेट ऑन द एक्चुअल रिकर्शन कैसे करना है. यू आर ओनली इन अ कंपैरिजन मोड, सर लूप इज बेटर और रिकर्शन इज बेटर. I would say that that is the biggest mistake that we are doing. Or many times we started with the problem. I seen that, you know, um, ऐसे में बीच में जो कुछ कहीं पर तो कोई तो वीडियो चेक कर रहा था, एंड देन इन दैट वीडियो दैट यू नो दे वर ट्राइंग टू एक्सप्लेन how to do recursion. The example it was taken was saying that print number 1 to 10 using recursion. Now print number 1 to 10, first of all, is it really a problem worth recursion? Again, ये कर सकते हैं नहीं कर सकते ये क्वेश्चन नहीं है. क्वेश्चन इज दैट इज इट रियली अ प्रॉब्लम वर्थ रिकर्शन? Not really. So you start with such kind of example. So मुझको 1 to 10 using recursion print करना है. So there are always chances you are always thinking in terms of how to convert loop into the recursion. So you're not learning recursion. You are trying to learn how to convert loop into the recursion, and that is the biggest mistake that you are doing. Recursion is not designed for such stupid problems which can be easily solved using loop. तो सर रिकर्शन किसके लिए है? रिकर्शन इज देयर फॉर सम रियली कॉम्प्लिकेटेड प्रोग्राम्स जिनको अगर आप लोग लूप से करते हो तो आपकी वाट लगती है. सर कुछ एग्जांपल्स आर लाइक क्विक सॉर्ट, एग्जांपल इज लाइक मर्ज सॉर्ट, एग्जांपल इज लाइक प्री ऑर्डर, in order, post order using recursion. Now these are few problems for which recursion divide and conquer technique is designed. These are certain example जहां पर divide and conquer technique is designed. So if you at all want to make a judgment, sir loops are better or recursion is better, you should not make it in a very early phase. I would recommend wait till we learn quick sort, till we learn merge sort, till we learn in order, pre-order, post-order. And when you learn all of them, at that time you go and compare. You compare कि इसको अगर मैं लूप से करूंगा तो कौन सा अच्छा होगा, इसको अगर मैं रिकर्शन से करूंगा तो कब अच्छा होगा. So when you really solve a problem which is worth that technique, then you should compare. So you compare on a simple problem and you say नहीं नहीं sir इसको तो मैं ऐसे ही solve कर लूंगा. So and you pass a judgment saying that sir loops are very easy than recursion. I guess स्टार्टिंग पॉइंट ही गलत है। तो एनीवे, तो सर क्विक सॉर्ट से शुरू करो। आई कैन नॉट, बिकॉज इफ आई स्टार्ट डूइंग दैट देन यू मे नॉट अंडरस्टैंड रिकर्शन वेल। Correct? You may understand application of recursion well, but may not understand recursion as such. So getting back to the point, so I was trying to tell you what is recursion, how to write recursive function. Just to summarize, how to write recursive function, explain the process in terms of itself. So given any problem statement, so let it be, so मुझको number करने 1 to 10 print करने, can I do recursion? I said yes, you can do recursion, provided you think, provided you think how do you explain the problem in terms of itself. How do you explain the problem in terms of itself? So you want to print the number 1 to 10, you want to print the number 1 to 10, even that can be done using recursion. But how? Let's say for example, I say that minimum is 1, maximum is let's say 10. मैं रिकर्शन नहीं पढ़ा रहा हूं, मैं थिंकिंग एबिलिटीज पढ़ा रहा हूं। बाद में ये मत कहना सर वो आपने डेटा स्ट्रक्चर में थिंकिंग कैसे करना है ये समझाया नहीं, वही समझाने की कोशिश कर रहा हूं। रिकर्शन इज समथिंग जो आपको शायद पहले से भी आता है। आई एम नॉट स्पेंडिंग टाइम ऑन रिकर्शन, आई एम स्पेंडिंग टाइम on a technique, divide and conquer technique. So I'm trying to tell you how to divide the problem. Please understand. So I'm saying that I want to print a number 1 to 10. So don't think from the loop perspective. Loop हमको नहीं आता है, and say that 1 to 10 I want to print it like using recursion. So you first understand, given a problem, can I put it like a divide and conquer fashion? Can I put it as a divide and conquer fashion? So I say that you consider the minimum number as 1, maximum number as 10. So you print the minimum number, listen carefully, you print the minimum number, and then now you say that that part is done. Now you look at 2 to 10, I want to print it using recursion. Again you print the minimum number 2, and again you continue further, I want to print 3 to 10 as a recursion. And again you print 3, and again you put a recursive call, I want to print 4 to 10 as a recursion. Now this is a way I'm thinking the same process in terms of divide and conquer. So यहाँ पर आपके पास कुछ तो मिनिमम है, आपके पास कुछ तो मैक्सिमम है. Can you please tell me what should be the base condition of this? अभी जो मैंने आपको एक्सप्लेनेशन किया, based on that, can you please tell me what could be the base condition of this? Terminating condition इसका क्या होगा? Terminating condition क्या होगा? Yes, Prasad, that is good. So don't hard code with the number. You simply say that जहां पर आपका मिनिमम और मैक्सिमम सेम हो जाएगा, जहां पर आपका मिनिमम और मैक्सिमम सेम हो जाएगा, so that is something the last number that you have to print, and then you do not want to make a recursive call. I hope you got the point. तो what I'm trying to tell you is that anytime ये आपको इंटरव्यू में होगा, 100% होगा कि some problem statement is been given and then they are asking solve this using recursion. So what they want to see, they want to first see how you are thinking about recursion. आगे जाके ऐसे कुछ प्रॉब्लम स्टेटमेंट हम लोग लेंगे, लाइक फॉर एग्जांपल repeat again, okay, no problem. So what I'm saying is that I'll take up the same example once again. See, कुछ obvious examples है, ये मैंने already बताया, so I'm not repeating the same example. I'm trying to tell you that some examples which are not obvious, some examples which are not obvious, those example how to do it using divide and conquer. Factorial looks very obvious, formula आपके पास recursive formula ही है, तो इसमें explain करने लायक ज्यादा कुछ नहीं है, जो आप लोगों ने सोचा है उसको कोड में कन्वर्ट कर दो, it is very easy. I'm talking about the second angle. What is second angle? कि जहां पर some problem statement is given, so what is your first thing? Don't think of how do you write a code. You first think of given a problem statement, उसमें ऐसा कौन सा part है जो आप लोग explain कर सकते हो in terms of itself. Given a problem statement, उसमें से कौन सा part है जो आप लोग explain कर सकते हो in terms of itself. Like for example, the same example I'm repeating once again. I want to print 1 to 10. I'm printing 1 to 10. I'm saying that don't think in terms of loops. Loops को बाजू में रखो और ये सोचना चालू करो, यार 1 to 10 print करना. The problem statement is print 1 to 10 or print between two numbers. All numbers between two numbers. 1 is the starting and 10 is the ending is an example. कल ऐसा भी होगा कि print 11 to 20. कल ऐसे भी होगा print 1 to 100. It could be anything. I'm saying that दो नंबर के बीच के सारे नंबर्स मुझको प्रिंट करने हैं using recursion. So you start thinking how I can think in terms of divide and conquer. So in this particular case, what is the minimum range? What is the maximum range? minimum range and maximum range. So minimum number you print, and after that, now you want to focus on minimum plus 1 to maximum. So अगर 1 to 10 का example लेते हैं, you print 1 and then you focus on 2 to 10. Again you take 2 out, or you print 2 and then you focus on to 3 to 10. So probably your recursive call will be something like min plus 1 comma max. That will be kind of your recursive call. And this way if you just continue all the way, कहाँ पर जाके आपको रुकना पड़ेगा? और probably you need to wait. आपको जाके रुकना कहाँ पर है? आपको रिकर्शन कहाँ पर रोकना है कि यहाँ से आगे रिकर्सिव नहीं हो सकता, जहां पर आपका मिनिमम नंबर और मैक्सिमम नंबर इट इज गेटिंग मैच्ड, क्योंकि अभी इसके आगे जाने का कोई मतलब ही नहीं है. As you understand this, that will be the kind of end condition, or that will be kind of base condition of recursion. I hope, Eknath, that is clear. Yes. So this is something I'm trying to explain. तो ऐसे जाके आगे जाके प्रॉब्लम आएंगे क्या? आएंगे. Like for example, how to reverse a linked list. Now how to reverse a linked list, to be frank, this is not obvious recursive choice. इसको लूप से आसानी से कर सकते हैं. लेकिन अगर कोई हमें इंटरव्यू में पूछता है कि आई वांट टू सी योर थिंकिंग, सो यू नीड टू फर्स्ट स्टार्ट थिंकिंग ऑफ, ओ लिंक्ड लिस्ट को अगर मुझको रिवर्स करना है तो मेरी डिवाइड एंड कॉन्कर टेक्निक क्या होनी चाहिए. सो आपको पहले वो टेक्निक पहले खुद को समझाओ, बाद में इंटरव्यूअर को समझाना, एंड देन यू स्टार्ट राइटिंग अ कोड. समवेयर यू स्टार्टेड राइटिंग अ कोड, आप रट्टा मार के आए हो कि डिवाइड क्या दैट यूजिंग रिकर्शन लिंक लिस्ट कैसे सॉर्ट करना है. यू रिटर्न 4 लाइंस ऑफ कोड, 4 लाइन में हो जाता है. सो यू रिटर्न 4 लाइंस ऑफ कोड एंड यू से दैट दिस इज डन. देन इंटरव्यूअर कंसिडर दैट you are the one who are memorizing, you are not the one who can thinking ability. I'm wasting too much of time. I believe I should go back and I should continue further. I believe almost everyone has understood it. How to write the recursive function. And my piece of advice is very simple. When you are writing recursive function, do not think of how it will execute. Now, once you understood how to write the function, how do you do that? That is good. And now go on the next step. What is the next step? Sir, recursion हमने लिखा तो सही, but sir ये execute कैसे होगा? Now it's time that we will talk about ये execute कैसे होगा. Let me first of all take you on a mathematics. Let me take you on a mathematical one. So पहले मैं आपको mathematically बताता हूँ how it is going to be executed, and then we will go on a code. So जब हम लोग mathematically हम लोग कहते हैं 4 factorial is equal to 4 into 3 factorial. Okay, good. 3 factorial equal to 3 into 2 factorial. 2 factorial is 2 into 1 factorial. 1 factorial 1 into 0 factorial, and 0 factorial is equal to 1. Oh, I see all these examples. नाउ कैन यू प्लीज टेल मी, अब एक्चुअल सॉल्व कैसे होता है? एक्चुअल सॉल्व कैसे करना है? ये जो जीरो फैक्टोरियल है इसका रिजल्ट है 1 ना. ए जीरो फैक्टोरियल का रिजल्ट है 1. दैट रिजल्ट ऑफ जीरो फैक्टोरियल यू नीड टू पुट इट इनटू द अर्लियर स्टेप. नाउ यू से 1 into 1. A 1 into 1 is still 1. The result is 1. That 1, you want to put it into the earlier step. This is 1. The result comes out to be 2 into 1 is 2. You put it into the earlier step. It is 2 over here. 2 into 3 is equal to 6. I got the result is equal to 6. You put 6 into the earlier step, and 6 into 4 comes out to be 24. Oh, that is great. I got something simple, 24. This is what my result. बाय द वे, मैथमेटिक्स में जब हम लोग ये सब कुछ करते हैं इसको क्या कहते हैं? डज एनीवन नो? अभी जो कुछ भी मैंने प्रोसेस दिखाया, दिस प्रोसेस इन मैथमेटिक्स व्हाट इट इज कॉल्ड एज? आई एम आस्किंग यू, इन मैथमेटिक्स व्हाट इट इज कॉल्ड एज? No, this is not permutation combination. This process you can just go back. I learned somewhere early, back substitution. This method is called a back substitution. The result of next step you put it into the previous step. Result of next step you put it in the previous step. Result of next step you put it in the previous step, and this way you go. This is referred as back substitution. Yes, Ameya, that is correct. ऐसे कुछ एग्जाम्पल अगर आपको चाहिए, कभी डिटर्मिनेंट सॉल्व किया? डिटर्मिनेंट वैल्यू। सो डिटर्मिनेंट वैल्यू इफ यू आर ट्राइंग टू सॉल्व, आई गेस वहां पर एक कुछ तो रूल होता था, क्रैमर्स रूल और समथिंग लाइक दैट। द क्रैमर्स रूल एज यू ट्राई टू सॉल्व, दिस इज अ टिपिकल एग्जाम्पल ऑफ लाइक अ रिकर्सिव फंक्शन। मुझको मैथमेटिक्स में नहीं जाना है, बट यू नो समवेयर डेटा स्ट्रक्चर थोड़ा बहुत मैथमेटिक्स से रिजेंबल करता है, तो जहां पर पॉसिबल एग्जाम्पल वहां पर मुझको बताने चाहिए, सो मैं बता रहा हूं। अगेन इफ यू आर एम्बिशियस प्रोग्रामर्स, मैं डबल कोट्स में कह रहा हूं, इफ यू आर एम्बिशियस प्रोग्रामर एंड इफ यू एट ऑल थिंक नहीं सर ये बेसिक प्रोग्रामिंग करके मेरे को बहुत बोर होता है, सो ये मैंने बचपन से किया हुआ है, अब सर मेरे को कुछ नए असाइनमेंट चाहिए, तो जब भी मैं ऐसे कुछ चीजें बताता रहता हूं, सो दीज आर द हिंट्स फॉर यू। इफ यू आर एम्बिशियस प्रोग्रामर, go ahead, recall Cramer's rule, try to do it using recursion. So is it simple or not simple? That is the reason I'm saying that I do not give such assignment to everyone. But जिन लोगों को ऐसे लगता है सर क्या ऐसे बोगस असाइनमेंट देते रहते हो, हमें सर अच्छे वाले असाइनमेंट चाहिए, and if you believe that your level is up to that par, go ahead, take it as an assignment and start solving. Okay, so it is up to you. I'm just going back. Hey, this is a back substitution and this is what how it is solved. नाउ मैथमेटिक्स में क्या होता है ये हमको समझ में आ गया कि नेक्स्ट स्टेप का रिजल्ट प्रीवियस स्टेप पे जाता है, बट सर कंप्यूटर्स में कैसे होगा? कंप्यूटर में नेक्स्ट स्टेप प्रीवियस स्टेप होता है और ये उसको ट्रैक करना पड़ता है। सर वो ट्रैक कैसे करते हैं? let me just go back, and the best way I learned this method, you know, from the literacy book, ki the best way to visualize it better, to visualize this better, you you write it in this step. You write the same function again and again. Like for example, I want to call a function result is equal to factorial of 4. ये कॉल हम लोगों ने कहां से किया? ऑब्वियसली ये कॉल हम लोगों ने मेन से किया। सो मेन से जब मैं कहता हूं रिजल्ट इज इक्वल टू फैक्टोरियल ऑफ 4, लेट अस जस्ट गो अहेड एंड मेक योर फर्स्ट कॉल. This is my first call where n is equal to 4. N is equal to 4. Is it equal to 0? Or not really, it is not equal to 0. So what you are making call? You are making call to factorial of 3. You are making call to the factorial of 3. So you making call to the factorial of 3. चलो यहाँ से हम लोगों ने factorial of 3 को फिर से call कर दिया, and where I can say that n is equal to 3. This is for visualization. ऐसे मत कहना and don't ask the stupid question, sir is it creating multiple copies of function? ऐसा मैंने कुछ नहीं कहा. So you first listen the whole stuff, उसके बाद में अगर कुछ क्वेश्चन होंगे तो पूछना. So now I'm saying that this is making call, and just to make it more visible, instead of showing arrow in place, because if I show the arrow in place again and again, there are likely chances are that you will be confused. So in order to make it more visible and more understandable, I'm saying that let me make a copy of that function so that you can see it well. So हम लोग call कर रहे हैं. So factorial of 4 is making call to the factorial of 3. Okay, that is good. Please note यहाँ पर n का value 4 है and you continued. Now you find that again the condition is false. Again n is equal to 3 and you are trying to make a call to factorial of n minus 1, or it is 2, and you are again making a call to this. Now the value of n is 2. Again this condition is false, and now you are saying that 2's factorial is equal to factorial of n minus 1. A factorial of 1 minus 1, 2 minus 1 is nothing but 1. You give a call, and it is 1. Oh, that is done. And you continue further. You say that if n is equal to 0, oh, condition is still false, n is equal to 1, and I'm simply saying that factorial of 0. Oh, factorial of 0, it is there. Oh, yes. And now you compare 0. What is it? If n is equal to 0, condition is true. You want to return 1. But where you want to return 1? Where do I want to return 1? You know the rule that function always return back to the place from where it is called. So जहां पर उसको last time call किया गया था वो वहीं पर return होने वाला है. The result will be ultimately returned to the place over here 1, and then 1 into 1. A 1 into 1, the result is once again 1. And that result 1 you are again returning to the previous place. Okay, that is great. Returning to the previous place. चलो यहाँ पर रिटर्न हो गया. ये वहां पर रिजल्ट क्या आया? 1 आया. Now the 1 into 2, यहाँ पर ऑलरेडी 2 है. A 1 into 2 is 2. The result is 2. that you want to return it to the previous place, previous call. So you have got like result 2, 2 into 3, 2 into 3 is equal to 6, or result is 6. The result 6, you want to return it back, or result 6, you want to return it back. So this is where the 6 is. So again you compare 6 into 4 is, let's say, 24, is, let's say, 24. So 24 is over there, and this 24 ultimately should be written from where it is called. It should be written from where it is called, where you get the result is equal to 24. Result is equal to 24. That's it. This is how the whole execution does. Don't you think that this is resembling quite the mathematical stuff that we talk about? So जैसे मैथ्स में होता है वैसे ही प्रोग्रामेटिकली भी होता है. Is the flow of execution is clear? So sir, why you take an example of factorial only? I take an example which people can understand very easily, but I do not advise कि आप लोग हर एक फंक्शन के लिए ऐसे पेपर वर्क करते बैठो, क्योंकि अगर आप हर एक के लिए ऐसे पेपर वर्क करते बैठोगे, इट विल बी वन ऑफ द टफेस्ट जॉब. स्पेशली जब हम लोग एडवांस फंक्शन में जाएंगे, समवेयर यू से क्विक सॉर्ट, मर्ज सॉर्ट और समथिंग लाइक दैट, दिस इज वेरी स्टूपिड वे, एंड दैट इज द रीजन आई ऑलवेज से दैट you learn how to write the function, you understand the first call of function, you understand the recursive process, you understand the base condition, and that's it. That's it. You should stop your journey there. You should not keep on drawing such kind of diagram for every single program that you are doing using recursion. If you are doing that, the likely chances are that you will be more confused. You'll be more confused. Factorial, power, छोटे छोटे function में चल जाता है approach. As the problems become complicated, you start doing it in this way, the likely chances are that you are more confused than more understood. But by the way, one last question about recursion, then we will wind up the recursion. The last question regarding this, the question is, तो सर फंक्शन के मल्टीपल कॉपीज क्रिएट हो रहे हैं क्या? नॉट एट ऑल. फंक्शन के मल्टीपल कॉपीज क्रिएट नहीं हो रहे. तो सर उसको कैसे पता चल रहा है कि मुझको यहां से कहां पर जाना है? सो राइट नाउ आई सेड दैट फ्रॉम हेयर द कॉल इज डन ओवर हेयर इटसेल्फ. Again next time call is done from here itself. Again next time call is done over here itself. So as long as ये अगर बार बार चल रहा है and the same call is made again and again, how does it keep track? ओ यहां से रिटर्न जब लास्ट टाइम खत्म होगा तो यहां से रिटर्न कहां पर होना है, यहां से खत्म होगा तो यहां से रिटर्न कहां पर होना है, यहां से खत्म होगा तो यहां पर रिटर्न कहां पर होना है, सबसे पहले जब यहां से रिटर्न होगा तो यहां पर रिटर्न होना है. हाउ इट कीप ट्रैक? ओ दैट इज अ काइंड ऑफ अ क्वेश्चन, and that is depending on how your execution is done. And how the execution is done irrespective of programming language, let it be C, let it be C++, let it be Java, let it be C sharp, let it be Node.js, इतने कुछ लैंग्वेजेस तो एटलीस्ट पाइथन, इतने सारे लैंग्वेजेस मेरे को पता है. तो हर एक लैंग्वेज में जब कभी हम लोग इसको कॉल करते हैं, जब कभी फंक्शन कॉल होता है, आई एम नॉट अ रिकर्शन, आई एम नॉट अ रिकर्शन, आई एम सेइंग दैट फॉर एनी फंक्शन कॉल, I repeat, for any function call, there is something called as a function activation record. Function activation record. And the function activation record is created on the stack. Function activation record, और by the way इसको ऐसे और भी एक नाम दिया जाता है, stack frame is created on stack for each, a for each, not function, for each function call. I do not say for each function, I say that each function call. So sir, when it is created, listen, it is created when call, when called, and at the same time it is destroyed when function returns. It destroyed when the function is returned, when function is called, when function called, and when function returned. By the way, what that function activation record contains is function activation record या stack frame जो भी आप लोग कहो. So what function activation record contains, इसके अंदर क्या क्या होता है? I repeat, ये irrespective of language है. तो ऐसे मत कहना सर आप जावा पढ़ा रहे हो, सी सी प्लस प्लस पढ़ा रहे हो। जितने सारे लैंग्वेजेस है, जहां जहां पर फंक्शंस होते हैं और फंक्शन कॉल्स होते हैं, उन हर एक लैंग्वेज में दिस इज एप्लीकेबल। इसको अंदर मेनली 3 चीजें होती है फंक्शन एक्टिवेशन रिकॉर्ड कंटेंट्स। 1, लोकल वेरिएबल्स। ए लोकल वेरिएबल्स, सो इफ यू टॉक अबाउट द अबव एग्जांपल, यहाँ पर r is a local variable. R is a local variable. I'm saying local variable. Second one, the second one, what is second one? Like arguments. You call it arguments, people call it as a parameters, whatever. So I'm saying that arguments, right? You can say formal arguments, function ke arguments. That is second. And a third thing, you call it as a return address, not return type. It is return address. Return address का मतलब क्या होता है? Return address simply means that address of next instruction, address of next instruction to be executed when function returns. And this seems to be, this is always the address of next instruction after function call. After function call. So what I'm saying is that अगर ये मेरा मेन का कोड है, हैव अ लुक एट दिस, अगर ये मेरा मेन का कोड है, जब मैं मेन के अंदर से इसको कॉल करता हूं, जब कभी मैं मेन के अंदर से जब इसको पहली बार कॉल करता हूं, एट दैट टाइम जब मैं मेन से इसको कॉल करता हूं, तो एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन, एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन, दिस इज नथिंग बट आई कॉल इट द रिटर्न एड्रेस। अब मैं कंप्यूटर हार्डवेयर के लेवल के ऊपर नहीं जाऊंगा, जस्ट अ पॉइंट टू नोट, ये जब मैं कहता हूं एड्रेस ऑफ नेक्स्ट इंस्ट्रक्शन, आई एम टॉकिंग अबाउट एड्रेस ऑफ नेक्स्ट असेंबली लैंग्वेज इंस्ट्रक्शन or address of next machine language instruction. I'm not really talking about address of next C instruction or Java instruction. I hope you got my point. Address of next मशीन लेवल इंस्ट्रक्शन। तो यहां पर जब भी एड्रेस रखा जाता है, वो आपके इंस्ट्रक्शन का एड्रेस रखा जाता है, मशीन लेवल इंस्ट्रक्शन का एड्रेस रखा जाता है। टू बी मोर प्रिसाइज, फॉर द बिगिनर लेवल, यू मे कंसिडर अच्छा यहाँ पर जो नेक्स्ट इंस्ट्रक्शन है उसका एड्रेस, बट टेक्निकली स्पीकिंग इट इज नॉट द नेक्स्ट इंस्ट्रक्शन। हाँ, yes, somebody is saying that it is program counter. Yes, Pallavi, Namrata, whatever you are saying is correct. It is program counter. मैं purposefully वो words avoid कर रहा हूँ कि program counter और instruction pointer, because you know people start saying that कि सर हमारा कंप्यूटर का बैकग्राउंड नहीं है, हमारा कंप्यूटर आर्किटेक्चर हम लोगों ने पढ़ा नहीं है, वगैरह वगैरह वगैरह। सो टू अवॉइड the reasoning and from the people, I'm just trying to keep it as a layman's language, address of next instruction to be executed after the function call. I believe this is clear, and if it is still not clear, let me just draw it bit more diagrammatically. I'd say that somewhere you have got, let's say, main. मैं assume कर रहा हूं कि यहां पर मैंने कहीं पर तो main लिखा हुआ है, और इसके अंदर res is equal to factorial of 4 मैंने कॉल किया। अगर res is equal to factorial of 4 कॉल किया है, तो यहां पर टेक अ लुक एट दिस, तो फंक्शन एक्टिवेशन रिकॉर्ड जो स्टैक के ऊपर क्रिएट होगा वो कैसे होगा? ओके, 2 मिनट, वी विल सी दिस मच एंड देन वी विल टेक अ ब्रेक। ओके, सो सबसे पहले आई एम सेइंग दैट लुकिंग एट द फर्स्ट वन, सबसे पहला फंक्शन एक्टिवेशन रिकॉर्ड, दिस इज ऑफ मेन, एंड इनसाइड मेन आपके जो वेरिएबल्स है, जैसे आपका res वेरिएबल है या argc argv वगैरह वेरिएबल्स होंगे, जो आपके वेरिएबल्स होंगे, दोज आर देयर इन फंक्शन एक्टिवेशन रिकॉर्ड। ए बाय द वे, वेयर मेन रिटर्न्स, मेन कहां पर रिटर्न होता है? हु कॉल्स मेन बाय द वे? आपके कोड के अंदर जो आप लोग मेन फंक्शन लिखते हो, हु कॉल्स मेन? यस, मेन इज कॉल्ड बाय ऑपरेटिंग सिस्टम, और अगर आप लोग जावा में हो देन मेन इज कॉल्ड बाय जेवीएम। ओके, वैलिड। तो जहां पर सर मेन किसको रिटर्न होगा? अगर हम लोग जावा में हैं तो हम लोग कह रहे हैं कि मेन इज कॉल्ड बाय जेवीएम, तो मेन के अंदर जो रिटर्न एड्रेस होगा, ए मेन के अंदर जो रिटर्न एड्रेस होगा, दिस रिटर्न एड्रेस विल बी दैट ऑफ जेवीएम, और अगर आप लोग C++ के प्रोग्राम में हो देन इट विल बी रिटर्न एड्रेस ऑफ द ऑपरेटिंग सिस्टम, लेट इट बी। अल्टीमेटली भाई साहब आपने ये पहले कॉल कर दिया, और इसके अंदर से लुक एट दिस, फ्रॉम हेयर यू मेड अ कॉल टू दिस, If you made a call to this, what will happen? A new function activation record is created. अब ये जो नया function activation record create होगा वो किसके लिए हो रहा है? So that new function activation record is created for factorial. It is created for the factorial. And inside factorial, have a look at this. Inside factorial, यहाँ पर हम लोग क्या कर रहे हैं? Factorial of 4. तो इसका जो argument है, argument क्या है? n. n is equal to 4 and r is kind of a variable there. It is a result variable that is stored there. Okay, that is good. This is nothing but will be there on a stack when this function is called. But wait, यहाँ पर तो result solve नहीं होने वाला है. From here, the call will be done to this. बाय द वे एक और चीज, यहाँ पर जो रिटर्न एड्रेस होगा, इसका रिटर्न एड्रेस क्या होगा? डेफिनेटली इट विल बी रिटर्न एड्रेस ऑफ योर मेन. It is going back to the main. A factorial function will be going back to the main from where it has been called earlier. Okay, that is good. Let us continue further. Let us continue further. What we want to see. So what will happen in next step? What will happen next step? It is in front of you. We are over here. We are over here. We are calling this. Now at that time, one more new function activation record will be created. A new function activation record will be created, and that new function activation record, it will have the value of n, let's say kind of 3. Result अभी तक calculate नहीं हुआ है, and where it is going to return? Oh, it is going to return to the earlier call to the factorial. It is going to return to the earlier call to the factorial. I hope you are getting the point. So और एक function activation record is created on the top of it. Okay, that is good. That is good. And let us continue further. From here, if from here again you make a call to the next call. When you made a next call, now what happened? When you made a next call, what happened? Again, one more function activation record is created on the top of this. On the top of this, ये जो function activation record है, ये वापस से factorial का ही है, और factorial का जो record यहाँ पर create हुआ है, वो क्या create हुआ है? वो f of 2, it is created. Okay, that is good. That is also fine. And if this is good, let us continue the same story once again. From here, you are again going to make the next call. You are going to make the next call, where it is n is equal to 1, where n is equal to 1, and with the n is equal to 1, you find that one more function activation record is created on the top of it. Where the argument passed is equal to 1. Okay, all right, and it will return back to the earlier call to the factorial. The last one to go for this. अब यहां से वापिस से एक बार हम लोग किसको कॉल कर रहे हैं? यहां से वापिस से हम लोग किसको कॉल कर रहे हैं? फाइनली वी आर मेकिंग कॉल टू द f of 0. Oh, we are making call to the f of 0 where n will be 0. As n will be 0, now you go back. This is what your basic one, ये already है आपके पास, but ये already आपके पास है, but there is like another function activation record created on the top of it. Created on the top of it, where value of n will be 0. Where value of n will be 0. That's it. This is done. So things are all right, things are comfortable. अब यहां से जब लोग कहोगे कि now I want to return from here to back, सर उसको back कैसे जाएगा? Because it will take the address from here. Taking address from here, it will be able to go back. And as it is going back, have a look at this. ये जो function activation record है, that function activation record will be destroyed. That function activation record will be destroyed, and you return back to the previous step. Sir, previous step से जब हम लोग वापस से return हो रहे हैं, we are returning from here to here. How we are returning from here to here? Obviously, at that time we are taking the return address from here. We are taking return address from here, and then we are going to the previous one. But when we are going from previous one, again the function activation record from here will be destroyed. A function activation record from here will be destroyed, and so on and so forth. You continue all the way. So by the time you reach back to the main, so you understand that जो factorial आप लोगों ने call किया था, the factorial function activation record is already destroyed, and finally you are into the main. जब आपका main खत्म हो जाएगा, even mains functionality record will be destroyed, and you go back to the JVM or operating system, whoever is there, you say that your program is terminated. Your program is terminated. I just explained you all the way how recursion works even at the lowest level. Lowest level. तो सर ये सारा नॉलेज जरूरी है. To solve the natural problems of recursion, this knowledge is not required. हाँ, जो ट्रिकी प्रॉब्लम्स होते हैं रिकर्शन के कुछ कुछ, तो वहां पर दिस नॉलेज मेक सेंस. दिस नॉलेज मेक सेंस. इज दिस क्लियर टू एवरीवन? I know it might be boring for you, but it was very much part of your syllabus. आपके पास already आपके साथ already सारा syllabus share किया हुआ है, so you can always go through, so you can find it out. Otherwise, I was not really planning to teach this once again because ये आपको पहले से आना चाहिए. जिन लोगों को नहीं आता है, so we learn from scratch once again and step by step understanding how execution is done. And I repeat once again, don't ever say that, sir Java में क्या करना है? Let it be Java, let it be C, let it be C++, whatever. Irrespective of programming language, it remains true because that is the way programs are executed in the operating system. अब बाद में कभी ना कभी आपके सिलेबस में ऑपरेटिंग सिस्टम भी है, तो आप लोग ऑपरेटिंग सिस्टम भी देखेंगे. कभी ना कभी हम लोग ऑपरेटिंग सिस्टम भी देखेंगे. तो जब आप लोग ऑपरेटिंग सिस्टम पढ़ोगे तो ऑपरेटिंग सिस्टम में ये सब कुछ आता है. ये सब कुछ आता है मतलब रिकर्शन नहीं आता है, बट द कंसेप्ट कम. विच कंसेप्ट कम? इट इज द क्वेश्चन. वेयर द स्टैक इज. हम लोग यहाँ पर स्टैक की बात कर रहे हैं, लेकिन स्टैक कहां पर है? ये फंक्शनल डिवीजन रिकॉर्ड इज क्रिएटेड ऑन अ स्टैक. फंक्शनल डिवीजन रिकॉर्ड क्रिएटेड ऑन अ स्टैक. फंक्शनल डिवीजन रिकॉर्ड क्रिएटेड ऑन अ स्टैक. वो ठीक है, बट वेयर इज द स्टैक? ओ वेयर इज द स्टैक? ओ गुड क्वेश्चन. नो, स्टैक के ऊपर होता है, लास्ट इन फर्स्ट आउट होता है, वो सब कुछ ठीक है, आई अंडरस्टैंड. बट सर वेयर द स्टैक इज? हाँ, इट इज रन टाइम डेटा एरिया. यस आई नो, बट वेयर इट इज? अगर मैं आपको बताता हूं, ए शो मी द स्टैक. हाउ? वेयर? आंसर इज वेरी सिंपल. द स्टैक. नहीं, आप लोगों ने जो कहा आपका आंसर रॉन्ग नहीं है, सिर्फ एक लेवल आपने बीच में छोड़ दिया है. द स्टैक इज पार्ट ऑफ प्रोसेस. व्हाट आई सेड? स्टैक इज पार्ट ऑफ प्रोसेस. हैव यू हर्ड अ वर्ड प्रोसेस? प्रोसेस आपने कभी तो ये डेफिनेशन रटा होगा. प्रोसेस इज प्रोग्राम इन एग्जीक्यूशन. Huh, process is program in execution. Exactly. I'm talking about the same process. So I'm saying that stack is a part of a process. And obviously process always run in a RAM. Process always run in a RAM. So ultimately this particular stack is also going to be present in RAM. So sir, what is process? Oh, process RAM में कैसे run होता है? That is a part of your operating system. But always understand that ये मत कहना सर वो आपने बोला stack होता है, लेकिन सर ये stack कौन create करता है? वो कहाँ से आता है? Correct? These things are part of your operating system module. तो उसके बारे में मुझको मत पूछना. This should be, I guess, clear. This is all about recursion and understanding of recursion, how recursion works, and etc. etc. I believe after this we will take a break for 10 minutes, and after 10 minutes break we will talk about actually writing a kind of a, ये जो बाइनरी सर्च हमने शुरू किया था, जो लॉजिक हमको समझ में आया था, वो लॉजिक हम लोग इसको इंप्लीमेंट करके देखेंगे. We will see how it goes, and after that we will move on to the sorting algorithms. कि which sorting algorithms are there, and then we will see couple of sorting algorithms for the today's session. फिलहाल के लिए it's 10 minutes break. You have any question? Please post. Let's get started back. So something that we were discussing was, binary search. And binary search, we are trying to put it like a recursive manner. And what is the recursive manner? We talk about the thought process. The thought process was pretty simple, I guess. Thought process is that you talk about beginning of the partition, you talk about end of a partition, you find the middle, check whether the middle is matching. If it is matching, if middle is matching, then simply return it. So find the middle, and if the middle is matching, simply return it. But if it is not matching, now there are two possibilities. Either it will be into the left partition, or it would be in the right partition. If it is onto the left partition, if it is on a left partition, I need to focus only onto the left area. I need to only focus onto the left area, like a left area, and left area is always from left to mid -1. If it is greater, the element that you want to search, if it is greater, if it is greater, then you continue and try to find out, and you try to find out like a mid +1 to right. So you focus only onto the right partition. So that is what logic. So you find that you focus onto the left partition or you focus onto the right partition. That is all logic that we need to write it, nothing extra or nothing special that we need to do. चलो आई अंडरस्टैंड दिस, बट जब भी मैंने आपको बताया था कि जब भी कभी हम लोग रिकर्सिव सोचेंगे तो इंपॉर्टेंट क्या है, रिकर्सिव सोचेंगे तो इंपॉर्टेंट क्या है, दो चीजें इंपॉर्टेंट है. एक तो यू शुड बी एबल टू एक्सप्लेन द प्रोसेस इन टर्म्स ऑफ इटसेल्फ. यस, आई एम एबल टू एक्सप्लेन द प्रोसेस इन टर्म्स ऑफ इटसेल्फ, बट व्हाट अबाउट टर्मिनेटिंग कंडीशन, व्हाट अबाउट द बेस कंडीशन, terminating condition or base condition, what should be the condition? Again you know it very well, you know it very well कि यहाँ पर अगेन आप लोग पेपर वर्क करते करते जा सकते हो. वैसे टू बी फ्रैंक अभी थोड़ी देर पहले हम लोग लूप से लिखा था, जब हमने लूप से सॉल्व किया था तो ऑलरेडी हम लोगों ने कंडीशन दिया हुआ है, दैट आल्सो यू ऑलरेडी नो. सो आप लोग वो टर्मिनेटिंग कंडीशन कि जहां पर आपको रुकना है, लेट्स से बेस कंडीशन इज इक्वल टू राइट बिकमिंग लेस देन लेफ्ट, राइट बिकमिंग लेस देन लेफ्ट इज गोइंग टू बी योर बेस कंडीशन. ये आपको पता है, अभी हमने थोड़ी देर पहले ही किया था. हाउएवर वेट फॉर अ मिनट, अगर आप इसको टेक्निकली सोचते हो, पेपर वर्क कर करके नहीं सर मुझको स्मॉलेस्ट लेवल तक जाना है फिर मुझको जाके देखना है, कर सकते हो. बट इंस्टेड ऑफ दैट व्हाट आई सजेस्ट और व्हाट आई रिकमेंड इज दैट व्हाट यू डू, what you think of the smallest possible array that you can give it. And what is smallest possible array that you can give it for the binary search? What is the smallest possible array that you can give it for the binary search? It is like only one element, and if there is only one element, there is only one element, it means that left and right will be equal. A left and right will be equal, left and right will be equal, जिसके लिए आपको इसको रन करना है. तो आपको ऐसी कंडीशन ढूंढनी पड़ेगी जहां पर लेफ्ट एंड राइट विल नॉट बी इक्वल, विल नॉट बी इक्वल, और जहां पर आपको रुकना है, एंड दैट अगेन गिव्स यू द सेम कंडीशन. आई होप यू गॉट माय पॉइंट. मैंने कहा आप लोग पेपर वर्क करके वहां तक जा सकते हो और फिर कर सकते हो, बट एज आई सेड दैट पेपर वर्क विल अननेसेसरी मेक इट कॉम्प्लिकेटेड. द मोर प्रॉपर वे, जब हम लोग डिवाइड एंड कॉन्कर एल्गोरिथम इंप्लीमेंट करते हैं, द मोर प्रॉपर वे इज दैट यू थिंक ऑफ द मिनिमल इनपुट दैट यू कैन गिव. द मिनिमल इनपुट, मैं फिर से एक बार रिपीट कर रहा हूँ, मिनिमल इनपुट दैट कैन बी गिवन फॉर अ बाइनरी सर्च विल बी लाइक अ सिंगल, will be the single array element. So array with only one element. array with one element के लिए आपको वो algorithm execute करना है. array with one element के लिए आपको वो algorithm execute करना है. तो obviously उससे कम जब होगा वहां पर आपको रुकना है. So definitely whenever, see that condition, whenever your array is bigger, it means that your left is smaller than right, left is smaller than right, I definitely want to run the algorithm. But if there is a single element, if there is a single element where left and right both are equal, I still want to execute that. So in which condition I do not want to execute? Where your right is becoming smaller than the left, or you say left is greater than right. कैसे भी लिखो, choice is yours. Choice is yours, and then you implement it. So you go ahead, जो अभी आपने कहा है उसको implement करो. तो सर आप नया फाइल बनाओगे क्या? I really don't think it is required. We will continue on to the same, and I will create a new function, but I'll create a new function. Let's add public static recursive binary search. मैंने जानबूझ के नाम चेंज कर दिया. I'm just calling it as recursive binary search, like a function that I want to write. And what I need to pass? I need to pass the array. अगर आप लोग ठीक से नोट करते हो, you need to also pass the left and you need to also pass the right. Okay, a binary search array and left right, and what I want to write, return, I want to return integer. So what logic you were applying? My logic was very simple. Let me first calculate the midpoint. A midpoint, मैं फिर से एक बार, अगर आप लोग नोट किया होगा, जब भी मैं कोड टाइप करता हूं, I talk. Trust me, I'm not really talking to you or talking for you. I'm talking to myself. That whenever I'm doing the algorithm, I'm thinking and revising, oh what exactly the process I need to do. मैं आपको इसलिए बता रहा हूं, मैं आपको इसलिए बता रहा हूं, तो सो दैट जब आप लोग प्रोग्राम टाइप करोगे, सो यू नीड टू ऑल्सो टॉक टू योरसेल्फ. ट्रस्ट मी, दैट रियली इंक्रीज द प्रोग्रामिंग स्किल. ये आपको बिलीव नहीं होगा, बट दैट रियली इंक्रीज व्हेन यू टॉक. बहुत बार ऐसे हमको लगता है कि नहीं शायद ये मेरे को पता है. आपको पता है, आपको लगना ये अलग बात है. एंड देन यू आर एबल टू पुट इट वर्बली, यू आर एबल टू पुट इट ऑन पेपर. दैट इज अ डिफरेंट स्किल. इससे थोड़ा सा काइंड ऑफ इंटरव्यू प्रैक्टिस होता है. और लाइक एटलीस्ट मेनी टाइम हमें समझ में आता है कि वॉट एवर दैट वी आर थिंकिंग was not up to the mark. So जब आप लोग verbally बात करते हो, so you are very clear about your own thought process. Again मेरी तरफ से suggestion है, choice is yours. हाँ, mid point. But this mid point I want to compare key is equal to error of mid. But where is the key? Obviously I need to pass the key also as an additional argument that I want to search. Okay, that is good. And you simply say that return mid. I found the middle element. But if it is not a middle element, then there are two possibilities. या तो ये smaller है या तो ये greater है. You continue further. If key is less than error of mid, key is less than error of mid, then recursively search, into the left partition, and your left partition is nothing but left to mid minus 1. Recursively search into left to mid minus 1. Okay, that is good. Otherwise, कहाँ पर गया? Left to mid minus 1. Otherwise, else I want to search in a right partition. But what is right partition? Right partition is mid plus 1 to right. I guess it is very clear. By the way, लेकिन आपको यहाँ से return क्या करना है? I want to return the index that is searched. Okay, you want to return the index that you have searched. So why don't I just declare one variable? And I collect the index that is coming from the internal call, and then I'm returning the same index. That's it. My code is completed. My code is completed without base condition. Yes, code is completed without base condition. Why don't I add a base condition? Oh, that is very easy. You simply say that when your left is greater than right or right is less than left, ये आपको जैसे लिखना है वो ऐसे लिखो. चलो मैंने स्लाइड में वैसे लिखा था, आई एम राइटिंग लाइक दैट. स्लाइड में मैंने क्या लिखा था? राइट इज लेस देन लेफ्ट. In that case, there is nothing much to be done. In this particular case, what to return? What is the meaning of this? What is the meaning of this? This partition itself is kind of invalid partition. You cannot have a partition where right is less than left. Not possible. So it only means that element is not found. Simply say return minus 1. That's it. But by the way, when you call this function, what all things that you need to pass? First of all, you need to pass the array. I understand. जब मेन में से इसको कॉल करोगे तो लेफ्ट और राइट क्या पास करोगे? जब मेन में से इसको कॉल करोगे, what you will pass in a left and what you will pass in a right? A left should be 0. Okay, that is good. But right should be the last index. What is the last index of the array? Last index of the array is always arr.length minus 1. arr.length minus 1. So as you understand that, go ahead and try to call it. Only change, I'm saying the recursive binary search, and now it is taking 4 arguments. Starting with first argument is 0, and the second argument, the right argument, is error of length minus 1. That's it. It's done. So is it finished? Yes, it is finished. So will it work? I believe so. Let's run it. Check it. 33. Oh, yes, it is working. 99. Yes, that is also working. And let me try to work 50. Oh, sorry, not found. So हम लोगों ने एक ही कोड हम लोगों ने linear search में लिखा है. It is giving the same result. Binary search, yes, it is giving the same result. And recursive binary search is again giving the same result. That's why it is printing thrice. I hope you people don't mind doing all these 3 things in a single project, because I purposefully done it in a single project so that it is more readable and more comparable. अगर मैं हर एक के लिए अगर नया प्रोजेक्ट क्रिएट करूंगा, हर एक के लिए अगर मैं नया फाइल क्रिएट करूंगा, इन माय ओपिनियन इट इज मोर कंफ्यूजिंग. देन यू नीड टू ओपन लाइक मल्टीपल फाइल्स, देन यू नीड टू ओपन लाइक मल्टीपल फाइल्स टू कंपेयर. अरे यार ये सही है, वो सही है, या फिर क्या चल रहा है, राइट? So I believe we need to take care of this. That's it. This is nothing but recursive binary search in front of you. चलो ले go through that. अगर आप लोग आपके पास है, कॉपी पेस्ट करो, रन करो. जिनको टाइप करना होगा वो हम मेरे साथ जब मैं एक्सप्लेन कर रहा हूँ तभी टाइप करो. उसके बाद में टाइप करोगे, इट विल टेक मच ऑफ टाइम. So good. It look like few people are doing it on the fly with me. That is good. Your typing speed is good. You can do it. If you feel नहीं नहीं सर मुझको सुनना है, I need to pay attention. I recommend that is your choice. But still copy paste and run it. At least at the end. कोड शेयरिंग एक्चुअली जिन लोगों को कोड शेयरिंग चालू हो रहा है वहां से ले लो. बाकी लोगों के लिए मैंने ऑलरेडी उसको शेयर किया हुआ है. गुड. तो सर इज इट एंड ऑफ सर्चिंग? Linear search, binary search, is it end of searching or not really? It is not really the end of searching. There is one more searching algorithm is there, which is very popular by the name of hashing. Hash tables are like another searching algorithm, and that we will be learning bit later, as I already told you. लेकिन वो एक सर्चिंग algorithm है which is more efficient. Linear search का time complexity we talk about like a O of n. Binary search का time complexity we talk about O of log n. And you will be surprised the hashing time complexity, ideal time complexity of hashing will be O of 1. I said ideal, not a real, but ideal it is O of 1. So it is probably much more faster as compared to this. Anyway, वो जब आएगा टॉपिक तब हम लोग देखेंगे. If this much is clear, should I move on to the next point? Done? Good. सो दैट इज ऑल अबाउट सॉर्टिंग सर्चिंग. बाय द वे इसमें हम लोगों ने एक बहुत बड़ा टॉपिक बीच में कवर किया. मेरे हिसाब से सॉर्टिंग सॉरी ये दो सर्चिंग एल्गोरिदम थे वो इतने ज्यादा इंपॉर्टेंट नहीं थे. उससे के अलावा जो टेक्निक हम लोग बात कर रहे थे और जो थॉट प्रोसेस हम लोग बात कर रहे थे, डिवाइड एंड कॉन्कर एंड रिकर्शन, in my opinion that was more important than these two simple searching algorithms. So sit with that, you visualize that, and you try to do जो भी आपको असाइनमेंट पता है. अनदर सिंपल असाइनमेंट, वो जो प्राइम फैक्टर का असाइनमेंट लिखा था, इट इज वर्थ, यू पीपल कैन गो अहेड, ट्राई टू डू इट बाय योरसेल्फ. इट इज नॉट डेटा स्ट्रक्चर असाइनमेंट बट लाइक अ रिकर्शन असाइनमेंट. तो यू कैन मेक योरसेल्फ मोर कंफर्टेबल. बिफोर आई स्टार्ट विद द सॉर्टिंग, आई जस्ट वांट टू रिमाइंड इट वंस अगेन. पर्पसफुली मैंने रिकर्शन पहले लेक्चर में पढ़ा है बिकॉज आई विल बी नीडिंग द सेम रिकर्शन अगेन इन द लास्ट लेक्चर. लास्ट लेक्चर में मतलब improvement on a recursion, we will probably discuss how the recursion can be optimized. बीच के जो algorithm होंगे like quick sort, merge sort या फिर binary search के, वो तब भी हम लोग recursion यूज करेंगे. But in that case जितना अभी हमने recursion देखा है उतना recursion काफी हो जाएगा. You go ahead, you talk about the next, what is that? Dynamic programming approach. Dynamic programming approach समझने के लिए by that time you should be comfortable into the recursion. Obviously you will get the chances in between as you will do the multiple ones. So जो लोग पहली बार पढ़ रहे हैं, please prepare. That is the reason वो पहले लेक्चर में लिया है, so that over the period at least 7-8 दिन बीच में अगर मिलेंगे आपको तो you can, जिन लोगों को कुछ नहीं आता है, so they should not keep crying in last lecture so it was too heavy, right? DP I'm talking about. तब होगा, नहीं तो अच्छे अच्छे लोगों को भी हेवी हो जाता है, but still better you prepare this, it will be things okay for you. And then now we will get started with some sorting algorithms. Sorting algorithms, again, arranging array elements in an ascending order or like a descending order. Okay, that is good. And then which all sorting algorithms that we have got? Oh, there are many. There are many. Some most popular ones जो है वो है selection sort, वो है bubble sort, वो है insertion sort. We have got like a quick sort, we got a merge sort, we got a heap sort. Apart from that, there is shell sort, radix sort, and many more. Oh, there are many more different sorting algorithms are available. However, these are few most common, most popular. Out of which ये जो पहले तीन है, they are like a basic ones. और जो अगले जो आपको दिख रहे हैं, these are bit advanced one, where you need some advanced data structures like either heap or you need a kind of a divide and conquer technique, right? तो our initial plan is that we will work on the basic algorithms. Again, मुझको सिलेक्शन सॉर्ट और बबल सॉर्ट में ज्यादा इंटरेस्ट नहीं है, बट आई यूजुअली टेक दिस algorithms early so that people get a practice of time complexity. So thinking in terms of time complexity, वो कुछ concept time complexity के पहले दूसरे लेक्चर में क्लियर होते हैं तो ज्यादा बेटर होता है, सो दैट यहाँ से आगे जब हम लोग लिंक लिस्ट पढ़ेंगे तो लिंक लिस्ट एट लास्ट, व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ एट लास्ट, even we need to ideally discuss the time complexity of each and every algorithm that we write. तो जब हम लोग एडवांस वाले algorithm लिखेंगे, at that time you cannot get into the time complexity. That is the reason the first lecture more focus is on given onto that. Let us continue further. We talk about selection sort. What selection sort algorithm is all about? The selection sort algorithm, again, let me first of all tell you the philosophy. Philosophy is very simple. You select one element, you compare with all remaining element. You select one element, you compare with all remaining elements, and that is the reason you call it as selection sort. Obviously, when you compare with another element, you want to put it like either in ascending order or you want to put it like a descending order. If you want to put ascending or descending order, when you are comparing, if necessary, do the swapping, interchange the position, interchange the position. So what exactly it means? We will take some example. Unless until example is taken, probably things may not be clear. It is, I know. So we will take up some example. And to take up example, have a look at this. Let's say that I have got some numbers. Let's say numbers are something like this. I can say that this is 6 or hmm, this is 6. This is, let's say, 8. This is, let's say, 1. This is, let's say, 4. This is, let's say, what is that, 3, and this is, let's say, 2. These are some numbers are there. I have just taken the numbers randomly. जो भी मूड आया है उस नंबर से मैंने लिया है. Obviously, again, I always recommend initially जब आप लोग पहली बार कर रहे हो, do it with the array that I have given and that array that I have shown. जब आप लोग वापस से लैब में करोगे, वापस से पेपर वर्क करोगे, at that time, if you are not confident, again follow the same input. Otherwise, you change the input, take some different value and try it again at as per your choice, right? So let us go ahead. What selection sort algorithm says? Selection sort algorithm says that you select one element. ये जो red color वाला है, it is a selected, and then compare with all remaining elements. Compare with all remaining elements. So what we are trying is that we are going to select, let's say 6, and then compare with all remaining. So you find that, by the way, हमको sort कैसे करना है? I want to do the ascending sort. Listen, I want to do the ascending sort. तो ये जो 0th element है, ये जो 0th element है, I have not selected 6 actually. I have selected the 0th element. The 0th element I have selected, and I need to compare with all elements after that. I need to select the 0th element and then I need to compare with all elements after that. Chalo, let us just get started. I have selected the 0th element, which is at the moment 6. You start comparing with the next element. और next element is, let's say, 4. अब आपको ascending sort करना है. Ascending sort में common sense, left element has to be smaller than the right element. In ascending sort, left element has to be smaller than the right element. If it is not, जो कि अभी आपको यहाँ पर दिख रहा है, if it is not, go ahead and sort it. Sort it in the sense swap it, interchange it. And if you have done that, continue on next element. Again, I find that 4 is greater than 2. If 4 is greater than 2, go ahead. Done. You continue further. Again, 2 is already less than 4, less than 8. Nothing much to be done. You continue further. Again, you find that 2 is less than 3. Nothing much to be done. Again, you continue further, but you find that 2 is greater than 1. If 2 is greater than 1, let us interchange their position, 1 at the beginning and 2 at the end. Whatever we have done, it is like completing one iteration or completing one pass. You ask the question, what we achieved in the first pass? What we achieved in the first pass is the smallest element come to its final position. Smallest element come to its final position. Okay, that is great. Let's continue further. Let's continue further. By the way, आपने 0th element को sort out किया है. What about the next? Oh, continue further. Now you select the element at the first position and start comparing with all elements after that. Start comparing with all elements after that. Let us begin. Now you find that 6 is greater than 4. 6 is greater than 4. What to do? Do interchanging. So 4 over here, 6 over here. Now continue on to the next. You find that 4 is less than 8. Nothing much to do. Continue. 4 is greater than 3. Oh, 4 is greater than 3. 3 comes over here. 4 goes there. You continue further. 3 is still greater than 2. A 3 is greater than 2. Do swapping. 2 comes at this place. 3 goes over there. That is all right. And again, your all comparisons are completed. All comparisons are completed. So I found that even the second element is in at place. सर अभी क्या करना है? रिपीट द प्रोसेस. प्लीज नोट, एल्गोरिदम पहले दूसरे बार में, पहले दूसरे इटरेशन में क्लियर नहीं होता है, but I'm very sure when you do the same process again and again, you automatically start getting clarity. So please keep paying attention. सारे डेटा स्ट्रक्चर के एल्गोरिदम ऐसे ही होंगे, एंड डू नॉट ओवर एक्सपेक्ट फ्रॉम योरसेल्फ. सर पहले इटरेशन में क्लियर होना चाहिए. आप खुद को आर्किमिडीज या न्यूटन या फिर व्हाट इज दैट, ऐसे कहते हैं बड़े बड़े लोग हो ऐसे समझने की कोशिश मत करना. Be normal. You are ordinary, I am also ordinary. So let us go step by step. At least you see that second time, third time, fourth time, things has to be clear. But keep paying attention. Okay, I'm repeating once again. ये पहले प्रोसेस, पहले स्टेप में हम लोगों ने क्या किया था? ये जीरोथ एलिमेंट, नेक्स्ट इसमें फर्स्ट एलिमेंट, नेक्स्ट इसमें सेकंड एलिमेंट, and now I want to compare the second element with all elements thereafter. Oh, I found that 6 is smaller than 8. Nothing to be done. 6 is greater than 4. If 6 is greater than 4, what is to be done? No problem. Let us swap 4 and 6. And if you swap that, this is done. Again, you continue further. Again, you continue further. Sorry, my mistake. Again, you continue further. Check the next element. Now, 4 is, just a minute. Let us continue further. And now again you find that 4 is greater than 3. If 4 is greater than 3, what is to be done? Let us swap that. Done. After third pass, you find that this element is reached to its final position. You continue the process. Select the next element, compare with all the elements after that. Now here you find that 8 is greater than 6. 8 is greater than 6. So 6 comes over here, 8 goes over there. Then compare the next. 6 is greater than 4. 6 is greater than 4. You take out 6 over here. 4 comes at the place. That is still fine. And then you go ahead. You repeat further. Now 8 you want to compare with all elements after that. 8 you want to compare with all elements after that. So you find that 8 is greater than 6. If 8 is greater than 6, you just do the swapping. That's it. और by the way, अब इसके बाद में करने लायक कुछ बचा नहीं है. If you have seen that, my whole array is in a sorted order. Whole array is in a sorted order. I hope you got that. Still, I will just go through the whole algorithm once again and we will do it once again. Now pay attention and do it with me. I say that not really try to do it with me. You will be like bit more comfortable. Now I want you people to participate into the discussion. Go ahead and start. What to do? What is the first? अब कौन सा element select करना है? You start by selecting zeroth element. You start by selecting zeroth element and you compare with all element after that. You start with the immediately next element. I said compare with all element after that, not from the beginning. Compare with all element after that. Okay. You start with what you are saying. If this element, if red color element, if it is greater than the blue color element, what I need to do? I need to do the swapping. Yes, thanks. So you replace 4 and 6. You find that 6 was greater than this, and again you continue. Again you find that if 4 is greater than 2. 4 is greater than 2. Yes, continue. Again you swap 2 and 4. Again you continue further. You have done that. You compare with the next element. You compare with the next element. 2 and 8. 2 and 8. Oh, no swapping is required. do not change it. Do not change it because 2 is already smaller than the 8. You continue further. 2 and 3. Again, I find that 2 is again smaller than 3. Again, nothing to be done. You continue further. 2 is greater than 1. As 2 is greater than 1, let us put 2 there. Let us get 1 there. And yes, we have done that. By the way, our whole pass is completed. What was our first pass? Our first pass was where we were saying that I is equal to 0. Please note, your first pass was I is equal to 0, and then you compared with all elements. You compared with all elements from 1 to 5. I is equal to 0 was the element that was selected. I is equal to 0 was the element that was selected, and you compare with j to 5. And what you achieved with this? How do you check कि आपने जो पास किया है सही किया है गलत किया है? How do you check? You find that जो ith element का जो भी element था, like a smallest number reach there. Okay? अब सर आगे क्या करना है? Take I to the next position. Take I to the next position and repeat the story once again. And again, you compare J to all elements after that. Compare with all elements after that. You continue. You find that, oh, 6 is greater than 4. 6 is greater than 4. What to do? Over here, 6 is greater than 4. What to do? Yes, I need to swap. So 4 over here, 6 over here. You continue further. Again, you find that 4 is greater than 8. 4 is, no, sorry, 4 is less than 8. If 4 is less than 8, no swapping is required. Okay, that is good. Now you find 4. Now next step, 4 is greater than 3. 4 is greater than 3. Go ahead, swap it. 3 over here, 4 over here, and you continue on to the next. Now you find that 3 is greater than 2. 3 is greater than 2. Yes, continue. Again, you want to take 2 over here. You want to take 3 over there. This is done. This is my second pass is completed. And I found that the second lowest element reached to its position. You continued further. You continue further. Now, you select the next element. You select the next element. So, element that is selected, I can say I is equal to 2 and j is equal to 3 to 5. So you selected 6. Continue. 6 is 6 is less than 8. 6 is less than 8. Do not swap. Continue further. 6 is greater than 4. 6 is greater than 4. Oh yes. 4 over here. 6 over here. It is going good. You continue further. 4 is greater than 3. Oh, 4 is greater than 3. Again continue. Again swap it. Oh, that is comfortable. All right. And this is done. So third pass is also completed. Why don't you continue? You select the next element and you go from the start. So now you are selecting third element and you want to compare with all element after that. Start. Start. What is to be done? 8. 8 is 8. You select that, you compare with this. I find that 8 is greater than 6. Oh, 8 is greater than 6. Go ahead, swap this. Not a problem. You continue further. Then continue. 6 is greater than 4. Yes, again swap. Okay, done. Over. And I found that this element reached to its final destination. The last step to repeat I is equal to 4 and you want to repeat j from 5 to 5. So I is equal to 4 and you want to repeat j from 5 to 5. And what I find? 8 is again greater than 6. If 8 is greater than 6, yes, go ahead. 6 over here, 8 over here. This is done and this element is also sorted. That's it. तो सर प्रोग्राम कैसे लिखना है प्रोग्राम कैसे लिखना है दैट इज वेरी सिंपल काइंड ऑफ स्टफ हाउ यू कैन राइट अ प्रोग्राम जिनको लिखना है आई गेस कुछ लोगों का लिख के भी हो गया होगा बट नॉट आई जस्ट गो अहेड एंड लेट अस whatever that we have understood Let us write it on a paper. Let us write it on a paper. What I understood is something like this. I need to start with I is equal to 0, I is less than 5, I plus plus. What I'm saying over here, take a look at this. This first loop is going from 0 to 4. A first loop is going from 0 to 4, and then for each of I want to compare with all elements after that. I want to compare with all elements after that. Oh, you want to compare with all elements after that? So each way, जब ये 0 था तब ये 1 था, जब ये 1 था तब ये 2 था, जब ये 2 था तो ये 3 था. I guess this is something that we were doing. You continue further. For j is equal to I plus 1, j is less than 6, where you have got 6 number of elements. 6 number of elements. So it is there. Yes. And then what do you want to do? Oh, you want to compare. If in which condition we have done the swapping? In which condition we have done the swapping? Swapping हम लोगों ने कौन से condition में किया था? When the selected element is greater than the further element. So you are saying that whenever a of I was greater than a of j, a of I was greater than a of j, we simply say swap the positions of a of I and a of j. मैं यहाँ पर कोड नहीं लिख रहा हूं, मैं यहाँ पर सिर्फ लॉजिक लिख रहा हूं. सर स्वैपिंग कैसे किया जाता है? स्वैपिंग यूजिंग टेम्पररी वेरिएबल, वो आपको आता होगा, वो हम लोग सीधा कोड में लिखेंगे, हम लोग जावा फाइल में लिखेंगे. द ओवरऑल लॉजिक मैंने आपको बताया, लॉजिक बताया, अब जाके कोड भी करते हैं ना. यस, वी शुड गो अहेड एंड वी शुड राइट इट इनटू द कोड. सो फाइल, अब सर्चिंग के कोड में मैं नया प्रोजेक्ट क्रिएट करूंगा. आई डू नॉट वांट टू मिक्स अप इनटू द सर्चिंग कोड, सो यू कैन से सॉर्टिंग. All right, we have got sorting, and into the sorting other class that I'm creating, sorting main. Sorting main, yes, it is there. That is good. Main, and you need to have some array for you is equal to, you can directly write like this. What is the array? 6, 4, 2, 8, 3, 1. सर ये दूसरे array के लिए काम नहीं करेगा? करेगा, लेकिन I always suggest that जो पेपर वर्क आपने किया है पहले उसके साथ चलता है क्या, पहले वो चेक कर लो. After that you can always take the values from the user and then you can try to print it once again. Absolutely no problem. So let's just go ahead. Public static void selection sort, and you are passing the array to that. Okay, I pass the array to that. What is to be done? जो अभी कोड लिखा था वही करना है. अभी कोड क्या लिखा था? I is equal to 0, I is less than 5. A 5 मतलब total 5 passes should be there. It should be only 5 passes. So अगर आपके पास 6 elements है, then there should be 5 passes. आपके पास 10 elements है, then there should be 9 passes, right? So we are saying that less than, yes, absolutely correct. Not array dot length, it is length minus 1, not length, length minus 1. And please note that हम लोगों ने counting 0 से शुरू किया है. Programmers, हमने counting 0 से शुरू किया है. Don't forget that. I is less than array dot length I plus plus. Okay, that is good. Then you want to compare with all elements after that. J is equal to 0, j is less than array dot length, correct? J plus plus, oh sorry, my mistake, length minus 1. यहाँ पर length minus 1 और यहाँ पर less than array dot length, क्योंकि ये 6 तक जाने वाला है. All right, I want to compare if array of I is greater than array of j. What do you want to do? I want to swap using a temporary variable. Okay, sorry, j, I want to check with all elements after that. A select ith element, what you are doing? Select ith element and compare with all elements after that. Compare with all elements after that. यही चीज अभी हम लोगों ने यहाँ पर लिखी थी. J is equal to I plus 1. Okay, no problem. And then you continue further. Array of I is equal to array of j, and array of j is equal to 10. That's a typical stupid swapping kind of logic. It has been written. Done. अब और कुछ बचा? Nothing much. You just go ahead and you want to print that array. Yeah, how do you print the array? आपको जावा आता है? How do you print the array in a single line? In a single line. Two-string method. So you want to say something like this: array.toString. Does it work? कैसे जावा प्रोग्रामर्स हो? हाँ, yes, Shubham, that is okay, that is good. So let me just make it better. It is arrays dot toString, correct? So this is something I am trying to do it. तो हम लोग पहला क्या कर रहे हैं? ये पहला डेमो है हमारा सिलेक्शन सॉर्ट का. सिलेक्शन सॉर्ट एंड ये जो है लेट्स से बिफोर, and I want to print it once again after sorting. Let's say after. All right. Obviously बीच में मुझको पहले फंक्शन तो कॉल करने दो. ये आपको अच्छा नहीं लगा, you can use normal for loop to print it. I don't bother about it. I do not unnecessarily want to increase my number of lines of code. And then you go ahead, run as Java application. I hope this is going well. Right? Chalo. Go ahead. Why don't you try it quickly? पहले कोड लिखो, go through that code, make yourself comfortable, ensure that logic is understood, and then definitely we need to talk about time complexity as well. The algorithm that we were discussing was selection sort. What is the again? So how to remember कि कौन से algorithm में क्या code लिखना है? I always remember the basic philosophy. Why the name selection sort came? You remember that you select ith element, compare with all element after that. Select ith element and then print all element after that. How to print pass count? How to print pass count? Why you want to print the pass count? Pass count is nothing but जितने बार ये loop repeat हुआ है. The outer loop is talking about your each and every pass. Amit, I guess you must have done something wrong with the curly brackets. Check the curly brackets and copy paste the whole code. That is something suggested. Copy paste the whole code. Only thing is that आपके क्लास का नाम और मेरे क्लास का नाम सेम होना चाहिए. अगर मेरे क्लास का नाम सॉर्टिंग मैन है, अगर आपका भी सॉर्टिंग मैन है, यू कैन लिटरली कॉपी पेस्ट द होल कोड. दैट विल मेक योर लाइफ बिट इजी. अगर आपने करली ब्रैकेट कुछ तो उल्टे सीधे दिए, कोई तो करली ब्रैकेट मिस हो गया, देयर विल बी प्रॉब्लम. और एक चीज, arrays डॉट सॉर्ट, arrays डॉट टू स्ट्रिंग के लिए, arrays डॉट टू स्ट्रिंग के लिए java dot util dot arrays need to be imported. Done? Oh, that is great. So things are going well. We all talk about like what is selection sort, that is in front of you. So there's nothing great. Just let us go on to the time complexity front. And going on a time complexity front, ये कुछ मुझको बता रहा है. By the way, हाँ, someone was asking that how to print the pass count. ऐसे से pass count print नहीं करना है. Pass count print करने का कोई मतलब नहीं है. जितना length होगा that -1 वो आपका pass count रहेगा. It is very easy. हाँ, if you just interested in knowing, sir, हर एक pass के बाद में output क्या आएगा? If someone is interested in knowing हर एक pass के बाद में output क्या आएगा, you can always go ahead and you can always print array in like each stage. If you're printing the array in each stage, you will be able to see जो हम लोगों ने जो पेपर वर्क किया था आपको पेपर वर्क दिखाई देगा. This was my pass 1 where 1 reach into the final place, 1 2 यहाँ पर second pass में 2 reach to the place, यहाँ पर 3 reach to the place, here 4 reach to the place, and then over here 6 reach to the place. I guess This is just for sake of testing, for printing after each pass. So if someone is interested in, सर हमने जो पेपर वर्क किया था वो पेपर वर्क और जो आपने यहाँ पर दिखाया वो, is it really matching? So you are able to print that. चलो, by the way, this is clear. हाँ, तो हम लोग कहाँ पर थे? We were going on to this. हाँ बोलो, what is to be done into this? How many iterations are happening? एक तो पहली चीज तो मेरे को देख के लग रहा है कि यहाँ पर लूप के अंदर लूप है. ओके, दैट इज गुड. लूप के अंदर लूप है, बट स्टिल द नंबर ऑफ इटरेशंस. कैन यू टेल मी व्हेन i is equal to 0, please pay attention, when i is equal to 0, how many iterations of the inner loop are done? When i is equal to 0, how many iterations of the inner loop are done? Inner loop के कितने iterations होंगे? When I is equal to 0, I'm talking about this element that you have selected, then 1, 2, 3, 4, 5 iterations. So I understand that on a first pass, there are total 5 iterations. 5 iterations. Okay, that is good. In a second pass, you are selecting this element and comparing with 1, 2, 3, 4. Okay, there are total 4 iterations. You continue further. On a next pass, you are selecting this element. 1, 2, 3 iterations. Okay, there are 3 iterations, and then 2 iterations, and last pass there is a 1 iteration. So total number of iterations of a inner loop, और इन अदर वर्ड्स, अगर आप लोग ठीक से नोट कर रहे हो, जितनी बार इनर लूप चल रहा है उतनी बार नीचे कंपैरिजन चल रहा है. हैव यू नोटेड? सो इन अदर वर्ड्स, टोटल नंबर ऑफ कंपैरिजंस और टोटल नंबर ऑफ इनर इटरेशंस. मैंने नंबर ऑफ स्वैपिंग्स नहीं कहा, आई सेड कंपैरिजंस. जितनी बार कंपेयर हुआ है, व्हाट इज टोटल कंपैरिजंस? सो यस, द टोटल कम्स आउट टू बी 15. ए टोटल कम्स आउट टू बी, 120 कहां से आया? Eknath, good morning. So 15, a 5 plus 4 plus 3 plus 2 plus 1, that comes out to be 15. Wait, by the way, sir, ये तो 6 का array था, इसलिए ऐसे हुआ. What about other? What about other? Now you can try to generalize the formula. आपका जो first iteration था, in a first iteration, it was n minus 1 comparison. On a, ये number of iterations में count कर रहा हूँ. On a second, it is n minus 2 iterations. Okay, that is good. In a third, it was, let's say, n minus 3 iterations. And what was there in last? Last there was like a 1 iteration. जहां तक मुझको समझ में आता है, it is a AP, arithmetic progression, isn't it? Is it a AP? Yes, arithmetic progression. And if it is arithmetic progression, can you please apply the formula? Can you please apply the formula of arithmetic expression, arithmetic progression? Arithmetic progression simply says that it is n into n minus 1 divided by 2. N into n minus 1 divided by 2. And you can cross check. When you got 6 elements, please compare. When you have got 6 elements के लिए total iterations कितने होते हैं? 5 into 4 divided by 2. No, sorry, 6 into 5 divided by 4. So 6 into 5 divided by 4 comes out to be 15. You are able to see there. Okay, that is good. But wait, we are saying that the time required is going to be proportional to n square minus n divided by 2. 1 by 2 is constant. ये सारी दुनिया को पता है. अगर 1 by 2 is constant, I can simply say it is n square minus n. Okay, that is all right. But wait, अब जो कह रहा है उसको ठीक से सुनो. ये आपके मैथमेटिक्स में आपने कभी तो बचपन में पढ़ा होगा. If n is large enough, what I'm saying, if n is large enough, then n square is much larger than n. Have you ever heard of it? Example, 1 का स्क्वायर 1 होता है, बट 10 का स्क्वायर 100 होता है, और 100 का स्क्वायर प्रोबेबली 10,000 होता है. सो जैसे जैसे नंबर बढ़ता है वैसे वैसे आपका स्क्वायर मच हायर रेट पे बढ़ता है. So with this, if you understand that, I said all lower order terms can be ignored or can be neglected. Because n square is much larger देन n. बाय द वे इसको क्या कहते हैं? व्हाट दिस इज कॉल्ड इन मैथमेटिक्स? ये जो कुछ भी अभी मैंने आपको बताया, इसको मैथमेटिक्स में क्या कहते हैं? ये जो फॉर्मूला है, लाइक n स्क्वायर इज लाइक, यस एब्सोल्युटली करेक्ट प्रसाद, आपका मैथ्स अच्छा है, गुड. सो दिस इज रेफर्ड एज थियरी ऑफ approximation. This is theory of approximation. It is called a theory of approximation, which is in front of you. And if you understand that, let me just ignore that, and I can simply say time required is proportional to n square, and hence time complexity is of order of n square. A time complexity is of order of n square. Okay, that's it. Nothing much. This is what all done. This is what selection sort algorithm is. By the way, if your array is already sorted, will it still take the same number of iterations? Please think. If your array is already sorted, will it still take the same number of iterations? Oh, likely chances are yes, because there is no way to find out whether the array is already sorted or not. And that is the reason, selection sort ये ऐसा sort है, has number of swapping will be zero. Whatever Shubham you are saying is correct. Number of swapping will be zero. However, number of, even the swapping are zero, number of iterations will not reduce. And that is the reason this sort cannot be improvised or cannot be cached. इसको optimize नहीं किया जा सकता. And that is the reason people usually say that selection sort is not a good choice when it comes down to the sorting algorithm. क्योंकि जैसे जैसे n बढ़ता जाता है, वैसे वैसे ये ग्रो होता जाता है, और आपके पास कोई ज्यादा solutions या ज्यादा कोई choices आपके पास नहीं होते. That is a fact. I believe this is what all the points that we want to discuss. What is selection sort and what is earlier one. Instead of starting a new sort today, I thought कि जो कुछ भी हम लोगों ने किया है, you should think of it and you should work on it. तो सर हम लोगों को क्या करना है? Look, a kind of assignment that you people is expected to do. Instead of teaching something new, I'm just trying to give you the idea कि आपको assignment क्या करना है. So please pay attention. The assignment is that you need to create an array of person. हम लोग जावा के एक्सपर्ट है, तो you can create a class person. You can create a class person, and class person you will be having the multiple entries. Let's say you will be having ID, you can have name, you can have age or something like this. You can also add address or whatever that you want. So here I'm just adding some values. Let's say ID is equal to 1, name is equal to, let's say, B, and then age is, let's say, 24. You continue further. The next ID is, let's say, 5. The name of a person is, let's say, X. The age is, let's say, 20. The another thing, let's say that it is ID 6. Let's say name of a person is, let's say, P, and then I'm saying that the age is, let's say, something like this. You continue further. You take values again. कुछ भी number ले लो, उससे कोई फर्क नहीं पड़ता. I'm just taking some random numbers. I'm taking some random numbers and some random values. So this way you just go ahead. Obviously ID same नहीं होना चाहिए. So we will take some different number and और कुछ बच गया. Anyway, P is already added. I can go with something different, Q, and then, all right. I want you people to first of all create array of person object, and not only create array of person object, swap the array using selection sort. Can you please tell me what logic that you need to build? अगर आपको array of person sort करना है, तो आपको क्या करना पड़ेगा? आपका आज का असाइनमेंट है, जल्दी जल्दी बोलो. अगर आपको array of person sort करना है using selection sort, what all changes that you will need to do? What all changes that you need to do? आपका जो सॉर्टिंग का एल्गोरिदम है, ये जो एल्गोरिदम आपको दिख रहा है, इस एल्गोरिदम में चेंजेस कहां पर होंगे? Which line that you might want to change? Obviously I want to sort. लेकिन सॉर्ट एग्जैक्टली द वेरी फर्स्ट क्वेश्चन दैट यू शुड बी आस्किंग, सर वो सॉर्ट करना है पर्सन, वो ठीक है, लेकिन पहले ये बताओ कि पर्सन के अंदर सॉर्ट किससे करना है? सॉर्टिंग बाय आईडी करना है, या सॉर्टिंग बाय नेम करना है या फिर सॉर्टिंग बाय कुछ और करना है? पहले किससे सॉर्ट करना है, पहले ये तो बता दो। दैट इज लाइक योर फर्स्ट रिक्वायरमेंट। ओके, आई अंडरस्टैंड दैट, किससे सॉर्ट करना ही हमारा पहला रिक्वायरमेंट है। तो चलो सॉर्ट बाय एज करना है, ए सॉर्ट बाय एज करना है। हाँ, क्रिएट एरे ऑफ पर्सन, आई एम एज्यूमिंग दैट कि अगर आपको सॉर्ट बाय एज करना है, कैन यू प्लीज टेल मी इन विच लाइन ऑफ कोड देयर शुड बी चेंजेस? आपके कोड में चेंज कहां पर होगा, ये मेरा क्वेश्चन है। विच लाइन आई नीड टू चेंज? Yes, absolutely. You people understand that. All I need to change is nothing but if. All I need to change is nothing but if. So what change should be there in a if? चलो go ahead, tell me. If में क्या change करना है? अब मुझको age से sort करना है, मैंने आपको पहले ही बताया, I want to sort by age. Yes, absolutely. All I need to do is that, all I need to do is that P this dot age is greater than this dot age. Is that all right? Is that all right? Yes, that is all we need to do. एक बात बताओ, should I do the changes into this as well? यहां पर भी चेंज करना है क्या? नहीं नहीं, स्वैप तो मुझको पूरा का पूरा पर्सन का ऑब्जेक्ट ही करना है। स्वैप तो पूरा का पूरा पर्सन का ऑब्जेक्ट ही करना है। आई डू नॉट वांट टू सॉर्ट लाइक ओनली एजेस, मुझको एज सॉर्ट नहीं करना, मुझको पूरा का पूरा पर्सन सॉर्ट करना है। तो स्वैपिंग लॉजिक विल रिमेन सेम, ओनली द कंपैरिजन लॉजिक विल चेंज। By the way, if I tell you कि I also want to sort not only using age, but I also want to sort using name, आपको क्या करना पड़ेगा? Probably आपको एक नया फंक्शन लिखना पड़ेगा and then you need to put a logic of comparison of name over here. I guess string में dot name dot compare to होता है, आप लोग compare to यूज कर सकते हो। बट अगेन मुझको बताना कि आपको आपको सिलेक्शन सॉर्ट के लिए एक नया कोड लिखना पड़ेगा, राइट? But what if I say that I want to change it by ID, I want to sort by ID, वापस से एक बार आपको सिलेक्शन सॉर्ट का एक और नया कोड लिखना पड़ेगा जहां पर एज की जगह पे आपको शायद आईडी यूज करना पड़ेगा। सो व्हाट एग्जैक्टली यू आर ट्राइंग टू टेल? आई एम ट्राइंग टू टेल यू दैट सी मेनू ड्रिवन कोड आप लोग बना सकते हो, इट्स नॉट अ प्रॉब्लम, बट एक सिलेक्शन सॉर्ट का लॉजिक आपको बहुत बार लिखना पड़ता है। हैव यू नोटेड दैट? उसमें भी अभी तो मैं सारे असेंडिंग सॉर्ट कर रहा हूं, इन फ्यूचर यू से दैट नहीं नहीं मुझको डिसेंडिंग सॉर्ट करना है। ये डिसेंडिंग सॉर्ट करना है, व्हाट डू यू डू? यू गो बैक, जहां पर ग्रेटर है वहां पर लेस देन करो, इट विल बी डिसेंडिंग सॉर्ट। बट प्रॉब्लम इज दैट, लिसन, प्रॉब्लम इज दैट ये कहना आसान है, लेकिन मैं क्या कह रहा हूं कि मेरे पास तीन है, आईडी है, नेम है और एज है। मुझको तीनों से सॉर्ट करना है, तीनों से सॉर्ट करना है, असेंडिंग भी करना है, डिसेंडिंग भी करना है। मुझको 6 बार एक ही फंक्शन लिखना पड़ेगा। आर यू गेटिंग माय पॉइंट? मुझको 6 बार एक ही फंक्शन लिखना पड़ेगा, और 6 बार एक ही फंक्शन लिखना, ये कहाँ की समझदारी है? तो सर, इज देयर इज एनी बेटर वे? Yes, there is a better way. What you people learn in a Java, you people learn generic methods, and you must have learned some comparator. So why not go to the sort method, write your own sort method, and take a comparator as an argument. Write your own sort method and take a comparator as an argument. Now please note, teaching comparator is not a part of a data structure module. I repeat, teaching comparator is not part of a data structure module. वो आपको ऑलरेडी आता है, आपने ऑलरेडी वहां पर पढ़ा हुआ है। बट यू नो, फॉर सेक ऑफ प्रैक्टिस मैं रिकमेंड करूंगा, फॉर सेक ऑफ प्रैक्टिस इट इज वर्थ गोइंग बैक एंड री राइटिंग फ्यू जावा कोड्स अगेन। इससे आपके दो फायदे हो जाएंगे, एक तो जावा रिवाइज हो जाएगा एंड यू विल स्टार्ट अंडरस्टैंडिंग बेटर कि जावा के जो रेडीमेड कलेक्शंस है वो बिहाइंड द सीन कैसे काम करते हैं। आई होप यू गॉट माई पॉइंट, करेक्ट? सो आई डू रिकमेंड, लेकिन रुको, लेकिन सी टू इट दैट कंसिडरिंग द टाइम इन अवर हैंड, it will not be really possible for me to teach or cover Java topics once again over here. So you have any problems? That is the reason I'm saying that. Go back, sit in a groups, discuss, lab faculties are there. And if you want something regarding assignment to be discussed with me, ideally before lecture or after lecture, that should be like ideal time where we can discuss about that. During lecture, we'll talk about data structure module and data structure syllabus. I guess it is too much of time. It's 1:34. We will stop over here for now. If anyone has got any questions, you can hold back. Otherwise, you can leave. Bye bye. See you.